Well, hello everyone. I hope I'm audible and clearly visible. Let me just check. Hello, hello, hello. Yes. I'm audible as well as visible. Great. Hello Kiran, how are you? Just a minute. So today we are going to revise and do all the practice of questions in permutations and combinations PNC. In class 11 generally we study this topic, but this chapter has a lot of weightage. Not only about this chapter questions or the concepts from this chapter are used in many chapters in fact. So today what we are going to do, we are going to see the questions of 2025. We'll learn all the concepts. It's a long chapter, it's a very big chapter because there are multiple varieties of questions involved in this chapter. So it's going to take a while for sure. But yeah, once you go through this lecture, I don't think you'll have any doubts remaining regarding the types of questions, because in today's sessions I've brought all the types which you can expect, and many PYQs are also there. So you'll feel pretty confident after doing this chapter today. So shall we start? I hope I'm clearly audible. No problem in that. All right. So we'll start permutations and combinations. Basically, this chapter is about counting. More than permutation means arrange, combinations means making combinations, permutations means number of ways in which we can arrange, the basic definitions you know. But this chapter is more about counting. Even if we don't study the concepts, even if we don't remember the formulas which are there in this chapter, even then we are going to be able to solve this chapter, to do the questions of this chapter, if we understand the fundamentals of counting, how we count. Right? If you are good at counting, counting does not mean 1, 2, 3, 4, 5. Obviously, it does not mean 1, 2, 3, 4, 5. Sir, there are 100 people. No. Number of ways. In how many ways you can do something, achieve something, select something, choose something, distribute something. So how well are you at counting? How good are you at making scenarios? This chapter is all about that. All right. So we are going to begin. Hi, this is Prathap. Okay. Thank you. All right. So the few things which I'm going to tell you in this chapter, what all it is about. Before that, I'll tell you how to study this chapter. You know, I've seen many students don't study the chapter of permutations and combinations in the correct sequence. Okay. So whenever you are studying this chapter, leaving apart the topics, what should be your approach? What should be your sequence of learning the topics or concepts of this chapter? So whenever you study like this, arrangement. First of all, study about arrangement. Right? Now, arrangement of like and, okay, let me make it here. So first we see arrangements. Arrangements, how to study arrangement? Arrangement of like objects and unlike objects. Then study the arrangement of unlike objects. How to arrange the unlike objects. Like means same, unlike means different. After arrangement, you study about selection. Choosing, or you can call it selection. Selection also of like objects and unlike objects. And third thing which you have to study is distribution. Only three things. This entire chapter is divided into three categories: arrangement, selection and distribution. Entire chapter is about this. Right? Distribution, also distribution of like objects, distribution of unlike objects. So study in this flow. Whenever you cover this chapter, whenever you are revising this chapter, revise also like this: arrangement of like and unlike object, selection of like and unlike object, and distribution of like and unlike object. This is how the flow of this chapter should be. All right. Okay, let's go ahead. Now, some fundamentals of counting, the basic things about counting which we should know. For example, like if I ask you to count these dots. So there is one way of counting 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Or what you can do, you can multiply the number of rows with number of columns. So this is just a method of Vanakkam Heisenberg. My God, that's a name. That's an impressive name. Right? So 6 of the columns you have, and similarly 5 you have rows. So 6 multiplied with 5, that is 30 rows. So, you know, it's just how better you can count, how much you understand the counting. So 6 into 5 is also one method. For example, next example we can take in how many ways we can choose a pen or a marker out of 5 pens and 3 markers. 5 pens are there and we have 3 markers. Okay, now pay attention over here. Let's say pens are P1, P2, P3, P4, P5. Okay, now what you have to choose a pen or a marker. In this question they are saying choose a pen or a marker. Sir, please take daily classes. Okay, Anushri, I'll try that. Okay, P1, P2, P3, P4, P5. There are 5 pens. Okay, Manasvi, good evening. 5 pens. Out of these 5 pens, we have to choose. We have to choose either a pen or a marker. So 5 pens are there and let's say markers we have M1, M2, M3. Right, 3 markers are there. Now there can be 2 types of question. This is one question, choose a pen or a marker, and another question says choose a pen and a marker. Choose a pen or a marker, choose a pen and a marker. Now if we have to choose a pen or a marker, that means we have choice. We are doing or. This word or is very important over here. So in how many ways I can choose one pen? I can choose P1, P2, P3, P4 or P5. So in 5 ways I can choose a pen and in 3 ways I can choose a marker. If I am supposed to choose a pen or a marker, then total number of ways will be added. Right? That means this gives me 8. But if my question is I have to choose a pen or a marker, suppose I have 5 pens and again I have 3 markers M1, M2, M3. Now I have to make 2 choices, that too simultaneously, one after the another. Right? One pen I have to choose and right after that a marker I have to choose, because I'm choosing a pen and a marker. In the last question I was choosing a pen or a marker, but here I'm choosing a pen and a marker. So now I can choose P1, along with that I can choose M1, or I can choose P1, M2, or I can choose P1, M3. Same I can do with P2, P2, M1, P2, M2, P2, M3. Right? This can be the way. Now total number of ways if I find out. So 5 pens are there, 3 markers are there. So total number of ways will be 5 multiplied with 3. That means in 15 ways, you will see 5 rows of 3 will be created. So 5 multiplied with 3, 15 ways. That's why we multiply the rows and columns. One reason for that. Right? There will be total 15 ways in which I can choose one pen and one marker. 2 things simultaneously I'm doing. I'm doing 2 things simultaneously. Now, let's bring it to the next level. For example, let's say you have 5 shirts, right? 3 pants and 2 tie, right? Or let's take 3 pair of shoes. 3 pair of shoes you have. Now, in how many ways can you dress up without socks or anything else, right? If you want these things, in how many ways can you dress up? You'll choose shirt number 1, pant number 2, tie number 1 and shoe number 3. That is one choice. But how many total number of attires you can have? So simple answer, because you are going to choose pant, shirt, tie and shoe simultaneously one after the another, you have to make 4 choices. You have to wear clothes. So that will be 5 multiplied with 3, multiplied with 2, multiplied with 3. That's it. 18 into 5. 90. Total 90 ways you will have. 90 attires you are going to have. You must be thinking, sir, just 5 shirts, 3 pants, 2 ties. This much we have and you are saying 90 attires. Yes, you can have, you can have 90 different attires if you want. Right? So this is one type. Let's take one more question. Let's say we are moving from one city to another and there are 3 ways to travel from, what is this? This is Mumbai. No, this is Delhi, this is Jaipur, this is Mumbai. Okay, Delhi, Jaipur and Mumbai. Alright, let's suppose we have 3 different cities and number of ways to go from Delhi to Jaipur are 3. Then number of ways to go from Jaipur to Mumbai are 2. So total number of ways. Now here also 2 questions can be made. One question can be, in how many ways can you go from Delhi to Jaipur or Jaipur to Mumbai? So your answer will be or is being used. Either you have to go to Delhi to Jaipur, from Delhi to Jaipur, or you have to go from Jaipur to Mumbai. So in that case, you will have 3 plus 2, 5 ways. Second question can be, in how many ways you can go from Delhi to Mumbai crossing Jaipur? So now you will be doing two things at a time simultaneously. First you will go from Delhi to Jaipur, then Jaipur to Mumbai. So let's say this is your route 1, or route 1, route 2, route 3. This is your route 4, this is route 5. So either you can choose route 1 and route 4, or you can choose route 1 and route 5. Similarly, you can choose route 2 and route 4, or route 2 and route 5, route 3 and route 4, route 3 and route 5. So total number of ways will be multiplied because we are doing two things simultaneously, one after the other. Alright, so that will be total number of ways will be 6. In 6 ways I can go from Delhi to Mumbai crossing Jaipur. Alright, let's move ahead. Let's pick up this scenario. I'm just giving you ideas how we actually think about counting. Right, it's all row multiplied with column actually. No problem in that. Now, let's say there is a cinema and there are 5 gates in this cinema. If I ask you in how many ways to enter and exit the cinema. In how many ways can you enter as well as exit the cinema? So 5 ways to enter, and we have to do two things. We don't have to watch the movie. We are just entering and getting out. So suppose we got from gate 1 and went out from gate 1 only. Suppose we got in from gate 1, went out from gate 2, got in from gate 1, went out from gate 3, got in from gate 1, went out from gate 4, got in from gate 1, went out from gate 5. So gate 1 itself is giving me 5 ways. Right. Similarly, or you can think like this, 5 ways to enter and 5 ways to exit. And because we are doing two tasks simultaneously, enter and exit simultaneously, and word is used, we'll just multiply and there will be 25 ways to enter and exit the cinema with or without watching the movie. Alright. Now, suppose if I add a constraint over here. In how many ways you can enter and exit the cinema such that you don't use the same gate to exit which you use for entering the cinema. For example, suppose you got in from gate 1, now you cannot get out from gate 1. That's the restriction. You cannot use the same gate to get out which you had for getting in the cinema. Alright, so in that case what will we have to do? A number of ways to enter still remain 5. All the 5 ways we can use for entering. But because we cannot exit from the same gate that we used to enter, now to exit we have just 4 ways left. So that will be 20 total number of ways in which we can enter and exit the cinema without using the gate to exit which we used to enter from. Alright, so this is also one scenario. This is how. Now, in tails and heads. Now see, this is actually very important. This particular variety. Understand this example and try to think here what is happening. Okay, now suppose you toss a coin for one time. You'll either have tail or head. Now suppose you do it 2 times. So first one head, second one head. First one head, second one tail. First one tail, second one head. First one head, second one tail. Like this. Or second one also head. Achha, this is tail and this is tail. So this will be tail. This will be tail heads. This will be heads and tails. This will be heads. So 4 scenarios you are having, right? If you do it for 3 times, you'll have 8 scenarios. Head, tail, like that. You'll have 8 particular scenarios. Now, my point over here is, what will be the number of outcomes when we'll toss the coin n times? When we tossed it 1 time, the number of outcomes were 2. When we tossed it 2 times, number of outcomes became 4. When we tossed it 3 times, number of outcomes became 8. So if we'll toss it n times, number of outcomes will be 2 to the power n. Obviously, number of outcomes are going to be 2 to the power of n if we toss the same coin n times. Right? Now suppose if we toss it 4 times, 5 times, you understand the number of. Now here what I'm trying to say is, very important point. This question is not only about the coins. We can use it for dice also. We can use it for question answers also. Right? Because one action which has n outcomes is repeated multiple times. For example, a dice, right? A dice. A dice has how many possible outcomes from one roll? From one roll we have 6 possible outcomes. 1, 2, 3, 4, 5 or 6 can come. So we have 6 possible outcomes. Now if we roll the die 2 times, suppose if we roll the die 2 times, number of outcomes, now what was happening here, number of outcomes from one toss are 2, and the number of times we are repeating the toss is in the power, right? Number of outcomes of one toss are 2 outcomes, head or tail, right? If we are tossing 2 times, then now this is the base, number of outcomes will be the base. How many outcomes we have? Possible outcomes from one action, 2. Now how many times are we repeating it? If we are repeating it 3 times, 3 tosses means 8 outcomes. Similarly here, one die has 6 outcomes. One roll of a die will have 6 outcomes. If we roll the die 4 times, the total number of outcomes will be 4. If we roll the die 2 times, total number of outcomes will be 36. We know it. If we roll the die 3 times, number of outcomes formed will be 216. So whenever an action which has n outcomes is repeated m number of times, I'm writing again, pay attention carefully. When an action has n outcomes, one action has n outcomes, and this action is repeated m number of times, then total outcomes which are going to come on m, total outcomes will be always n to the power of m. N to the power of m. For example, one more example we can take. Suppose one multiple choice question has option A, option B, option C, option D. One multiple choice question has 4 options. Suppose one multiple choice question has 4 options. Now, in how many ways can I answer 10 multiple choice questions? 10 similar multiple choice questions. Similar means they'll also have 4 options, right? One multiple choice question has 4 options. In how many ways I can attempt 10 such options? So what am I going to do? My action has 4 outcomes. So 4 will come in the base. How many times I'm going to repeat it? I'm going to repeat it 10 times. So that means 4 to the power 10 are the number of ways in which I can attempt these 10 MCQs. Good evening, Hero. How are you? All good? Okay. In how many ways can I attempt 10 MCQs? Like this. Suppose, now let's do a question. Suppose you have 10 true or false questions. Suppose you have 10 true or false questions. What do we have? We have 10 true or false questions. Now question is, in how many ways? Hi Harry, you guys won't be able to talk here. You'll have to talk. You'll have to take your chat somewhere else. Okay. Now question is, in how many ways can you attempt the 10 questions? In how many ways can you attempt the 10 questions? Just like this. Suppose 2 false, true, false, false, true, false, true, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this is the answer key. For example, this is the answer key. Now, in how many ways can you attempt? 10. Every question has 2 choices. Every question has 2 choices, either true or false. And you are repeating the same thing 10 times. So, answer over here will be 2 to the power of 10. That means in 1024 ways, you can answer 10 true or false questions. Okay, 10 true or false questions you can attempt. Yeah, Hero was here only just now. Alright, you can attempt 10 true or false questions in 1024 ways, 2 to the power of 10. In how many ways can you, in how many ways can you answer all of them correctly? Think about it. In how many ways can you answer all of them correctly? Just one way, because there is only one answer key. If you have provided that answer key, then only you are correct. All questions are correct. In how many ways your all questions are correct, and in how many ways all questions are wrong, that also will be one. Now, in how many ways at least one question will be correct? At least one is correct. In how many ways? At least one question is correct. Heisenberg? At least one question is correct. Simple, no? Total number of ways are 1024. At least one question should be correct. That means all should not be wrong. That means all should not be wrong. At least one correct means all should not be wrong. All are wrong only in one way. So there are 1023 ways in which at least one question will be correct. You understand, right? Why am I saying all are wrong is only one way? Because you have to give exactly opposite of the answer key. If in answer key it is true, you have to mark false there. False, then true there. So obviously, if one answer key for all correct, one answer key for all wrong. So at least one correct means total number of ways minus 1. Total number of ways to do this minus 1. So this chapter is just about how better can you think, and obviously a little bit of concepts will help. But how better can you think of the scenarios? When an action having m outcomes is repeated n times, total outcomes possible obtained are m to the power n. Very important thing, right? Very important thing. Many questions are just based on this concept. Many questions are just based on, please provide session PDF. Yes, Prem, I will provide. Definitely, I'll provide. I hope applications of derivative you guys got. And last lecture was PYQs, that also I have uploaded. Prem, I will upload. I will provide. Don't worry. Now, in how many ways can you attempt 10 MCQ questions, each having 4 options, and only one option can be correct? That, right? 10 MCQ questions, each having 4 options, having only one option can be correct. You know, right? 4 to the power 10. One action has 4 outcomes, and it is repeated 10 times. In how many ways can you attempt all questions correctly? All questions will be correct only in one way. Only one possible answer key will be there. In how many ways can you attempt all questions incorrect? Sorry guys, on my system it was showing no internet. That is why I had to check with the team. All right, let's go ahead. In how many ways Can you attempt at least one correct? Total number of ways -1. That's it. We already did this type of question. Right? Not a problem. Okay, let's move ahead. Now arrangement. How to arrange things. For example, we have, suppose we have this shelf we have, remove except this part. Suppose we have 5 books, or let's say 4 books. 4 books are there. Physics, chemistry, maths, and let's say biology we have, and we have to arrange in 4 different shelves. So now just think, imagine how can you do this task. You'll first have all the 4 books. First you'll take all the 4 books in your hand. Now you'll go to the first shelf. For first shelf, in how many ways can you fill up the first shelf? Either you'll put physics, you'll put chemistry, you'll put maths, or you'll put biology. Correct. So for this shelf you have 4 options: physics, chemistry, maths and biology. All 4 ways are there to do this, to fill up the first shelf. Now after filling the first shelf, you'll go to the second shelf. In second shelf, how many ways you have? 1 book is already kept. 1 book is already kept. For the second shelf, you'll have 3 ways to fill it up. Right? 3 ways to, if physics is kept, then chemistry, maths, biology. If chemistry is kept, likewise. So you'll have 3 ways to fill it up. For this 2 ways, and for this 1 way. So number of ways to arrange 4 things in 4 different places will be just 4 factorial. 4 into 3 into 2 into 1. As simple as that. 10 athletes are competing in a race. In how many ways can they occupy top 3 positions? Top 3 position. Position 1, let's say like this. Right? This is position 1, this is position 2, this is position 3. In the top, for the top position, in how many ways you can make a person at first rank? All 10 ways. All 10 ways are there. Right? Now, because one person is already in the first rank, for the second rank, you'll have 9 people left. So 9 ways to fill it up. For third rank, you'll have 2 people are already chosen for first and second. So for third rank, you'll have 8 people. So total number of ways will just become 10 into 9 into 8. Right? Why are we multiplying? Again, because we are doing one thing after the other simultaneously. That is why we are multiplying. Just picking up simple. 7 flags of different colors are available. How many ways can you transmit the signal by using 2 flags at a time by putting one above the other? 7 flags are there. You have to put up a signal by putting 1 flag over the other. That means you have 2 places to fill. Right? Out of 7, you have to arrange 7 things in 2 places. For the first place, you will have 7 choices. And now in the second place, you cannot use the same flag which you used in the first place. So for the second place, you will have 6. Now you have done these tasks one after the other. So you will have 7 into 6. That means 42. This is how this thing can be done. Any doubt till now? The network is okay, right? I hope the network is okay. Completely okay. Alright. The stream's current bitrate is lower than the recommended bitrate. Alright. Okay. In how many ways can a key of 3 digits be decided for number lock containing number 0 to 9? 3 digits. I didn't understand the question. Which one, bache? Which one, Manasvi? This one? This one? But they are saying that there are 7 flags and you have to just like 7 lights, 7 colors of lights, and you have to display signals using any 2 flags, right? By putting one over the other. Suppose green over the yellow means something. Green over the yellow means go slow, or yellow over the green means go little more slow, like that. Heisenberg says 7C1 into 2, correct. 7C1 into 2 also will give you same answer only, 42. Nahin. No. 7C1 into 2 how? 7C1, if you want to use selection over there, then answer would be 7C1. 1 flag you have chosen from 7. And next thing which you will have to do is from 6 flags, 1. That is why I am saying, if you really want to master permutations and combinations, na bache, 7C2, yes, 7C2 would be correct. 7C2 will be again 62 only. But I am saying that if you really want to get into the fields of permutations and combinations, always try to first think by counting, fundamental counting. Don't directly try to use NC1, NCR you know, all the formulas that we have, n plus r minus 1, c r minus 1 for distribution, for everything, right? So instead of that, I would say just think like we are counting. Just think like we are counting. Okay, 2 flags. So 7 choices for this one and 6 choices for this one. Why? Because for the top shelf, we can use any of the 7 flags, 7 choices. Then 1 flag is used, you cannot use the same color again. So now 6 choices, no? So 7 multiplied with 6. Both the things we are doing simultaneously, one after the other. So 7 multiplied with 6, that's why I said 42. I think now Manasvi is clear. In how many ways can a key of 3 digits be decided for a number lock containing numbers 0 to 9? 3 digits you need. Achha, you are not forming a number, right? Number of lock, now here they didn't say that you cannot repeat a number, right? They didn't say that you cannot repeat a number. There is no such condition. The lock can be 0, 0, 0, lock can be 1, 1, 1, lock can be 1, 2, 3, 0, 1, 2, 1, 0, 2, anything, correct? For every place, for the first place from 0 to 9, 10 numbers are there, right? So for the first place, I have 10 choices. Now suppose I use 0 over here, I can use 0 again. Suppose I use 1 here, then I can use 1 also again. So for second place also I have 10 choices. For third place also 10 choices. Total number of ways in which I can make a 3-digit code using the digits 0 to 9 can be 10 to the power 3, because repetition is allowed. Nobody said that there is no condition that you cannot repeat the number, right? You cannot repeat the number. You can repeat. Now those suitcase locks you must have seen, 0, 0, 0, 1, 0, 0. Generally 0, 0, 0 is there. Everybody can guess it. All right. How many 5 letters palindromes can be made using English alphabet? What is palindrome? Can somebody tell me what is a palindrome? Do we understand what do we mean by palindrome? Malayalam is a palindrome, right? Malayalam is a palindrome. Manam is a palindrome. M-A-N-A-M. Manam is a palindrome. Now tell me. Palindrome means, just for example, AKA is a palindrome. You read it from this way or this way, it's same only. For example, Malayalam, the M-A-L-A-Y-A-L-A-M. You read it from this side to this side or this side to this side. It's the same. So in how many ways a 5-lettered palindrome can be used in English language? Based on this particular concept, there were 2 questions which were asked in 2025 mains. I think on 22nd and 29th. We'll see those questions also. But just this approach. You want to make a 5-lettered word. 1, 2, 3, 4, 5. Malayalam. You understood, right? Meaning of palindrome. Can you give me an example of palindrome? OK is not a palindrome. KO is different and OK is different. Right? Malayalam, best example. 121 is a palindrome. Very good. Adityam says 121 is a palindrome. In 5-lettered palindrome you want to make using English alphabet. Now 5-lettered. That means center can be anything, right? 5-letter. So this will be 26 choices for the center place. Now whatever is coming here should come here. Then only it will become a palindrome. Right? Whatever is coming here should come here. For this one, how many choices do I have? Achha, palindrome cannot be of same letters. Palindrome should have different letters, right? All letters we are supposed to be, it should be mentioned, but it's not mentioned in the question. But yeah, race car, arey wah, nice Heisenberg. Race car is good one. Now 26 choices for the, because 26 letters in English alphabet are there, 26 choices for the center. Now whatever is coming here should be here. Think very wisely. Think. Now suppose 1 letter I have put over here, right? Now 25 choices I have for this one. Correct? For this one, whatever is going to come here will be here. So this does not have a choice. This has one choice only. Whatever is chosen here will be kept here also. Now for this one, 24 choices, and same thing will be happening here. Correct? Understanding my point? 26 choices for the middle letter. Now for this one, 25 choices, and this will have just one choice. Whatever you are choosing here, here also that thing, same thing you have to put. Here if you have 24 choices, here one choice only, because whatever you are choosing here, same thing will come over here. Getting my point? Suppose if you cannot put anything else over here. These will have one choice only. right? So in 26 multiplied with 25 multiplied with 24 ways, you can make a palindrome which will have 3 distinct letters. Okay, understood? Any doubt here? Right, now suppose we want, it's suppose the question was as it is. Suppose I'm not saying that we are not allowed to repeat. Suppose we are allowed to repeat. In that case, 26, 26, 26, because these two will have one choice only. Right, so 26 to the power of 3 will be the answer if this exact question is being asked. Sir, what is the palindrome for equation? Beta, equation is not a palindrome. Palindrome is just a word or number. For example, 121 is a palindrome. 123, 21 is a palindrome. Right, you read it from this side and this side, it's the same. As I said, Malayalam, Malayalam, Malayalam is a palindrome. You read it from here to here or here to here, it's the same word. That's what I'm saying. 26 to the power 3. Okay, chaliye, let's go ahead. Now suppose a tricolor flag is to be formed having 3 adjacent strips. Tricolor flag, right, Tiranga. 3 adjacent strips of 3 different colors chosen from 6 different colors. In how many different colored flags can be formed? Different colored flags, right? You formed using 3 adjacent. How many? Tricolor flag means there should be 3 colors. That means distinct. 6 different colors. We are choosing from 6 different colors. So suppose for the first strip, we have 6 choices. Then for the second strip, we'll have 5 choices only. For the third one, we'll have 4 only. So 6 into 5 into 4, 120 will be our answer. There will be 120 ways in which we can make a tricolor flag using 6 different colors. Correct? Any doubt? Any problem in this? Clear? Let's move ahead. In how many ways exams are there? 3 true false questions are there, right? In an exam, there are 3 true false questions. In how many ways one can attempt the paper if each question has to be attempted? Each question has to be attempted. 3 true false questions are there. One question will have 2 choices and same thing we are repeating 3 times. So 2 to the power of 3. Correct? Clear? 2 to the power of 3. Now, second part. One can attempt or leave the question. One can either attempt or leave the question. Now think. Now think. Now think. Now what has happened? Question had 2 choices. Either we can answer true or we can answer false if we have to attempt it. If the restriction is that you have to attempt the question, then the choice that you have, the one action will have 2 choices, either true or false, right? But if you have in the second part, in this part it is saying one can attempt or leave the question. If he is going to attempt, either it will be true or they'll say false. If he leaves the question, third choice is that he leaves the questions. You can also leave the question now. So one action has 3 outcomes and now the action is repeated 3 times because 3 true false questions are there. No, one question has 3 choices. So 3 into 3 to the power of 3. That will be our answer. That means 27. There will be 27 ways to attempt 3 true false questions, whether in case when you can attempt or not attempt a question. So one choice is not attempted, right? True, false or not attempted. 3 choices. One action has 3 different ways to be attempted. Alright. Now at least one question has to be attempted. At least one question has to be attempted. What should be the answer for this one thing? But in how many ways can you not attempt any question? Just think like this. In how many ways can you not attempt any question? Number of ways to not attempt all questions. That is going to be not attempt all questions. That means only one way will be there. You didn't attempt any of the question. How many distinct 6-letter palindromes can be made using letter A, B and C if each letter can be used at most At most twice. Aditya, you are asking this or you have some doubt related to this? Aditya, can you please reply quickly? Actually, I am thinking it should be solved with distribution. We'll have to understand distribution first. I'm thinking if the same way by okay, sir, can you explain? All right. But here we'll have to use, we'll have to nullify the repeated cases. Just a second. So it should be, if only 3 letters are there, then 3 multiplied with 3 multiplied with 27 minus, okay, you are saying each letter can be used at most twice. So you'll have to make cases, Adityam, in this case. If you're asking this question, let me read it again. How many distinct 6 letter palindrome? First of all, 1, 2, 3. Only 3 will have make because 6 letters, these will be 1, 1, 1. Right, these will be 1, 1, 1. Now you are saying ABC we have. So first case we'll take that where we are using, you can use at most twice. So if we are using 2 A's, then it will just give us 1 into 1, right? There will be just one way. Suppose we are using 2 B's, then again one way. If you are using 3 C's, 2 C's, then again one way, because you are saying at most, right? So 3 ways in which we can use 2 A's, 2 B's and 2 C's. Now for, let's say, we are choosing A, B and C, all 3 different, right? Because all 3 different will be 3 factorial ways. So 3 factorial, that means 6. I think the answer should be 9. Wait, just a minute. 6, 2 same and 1 different, A, B, C. Alright, 2 same, 1 different will be 3 ways. 2 same, 1 different will, and all 3 different will be 6 ways. So 6 plus 3, 9 should be the answer. Tell me, Adityam, if I have understood your question correctly. See, 6 ways in which you can, in which all these 3 from A, B, C will be different. So 3 options for this, 2 options for this, 1 option for this. Now if 2 are same, so there are 3 cases in which 2 are same, 1 is different. 2 A's, 1 different, 2 B's, 1 different, 2 C's, 1 different. In that case, total 3 ways will be there to do that. So total should be 9 ways. You tell me if this is correct, or if there is another answer, then I'll rethink about the question. Alright. Now number of ways in which you can not attempt any of them will be 1. So total number of ways in which you can attempt were 27, 3 to the power 3. Minus if you do this one in which you are not attempting anything. What will be the remaining number of ways? Remaining number of ways will be the number of ways in which you can attempt, such that at least one question has to be attempted. At least one question has to be attempted. Right? That means at least one you are attempting. Total ways minus the way in which you are not attempting anything, what will remain? The remaining will be number of ways in which you are attempting at least one question. So from 27, just remove that one way in which we are not attempting any of the question. Now, how many ordered pairs A, B? Now try to count this question, count in this question. How many ordered pairs A, B are there such that LCM of A and B is 3 to the power 4 multiplied with 7 to the power 3. LCM should be 3 to the power 4 multiplied with 7 to the power 3. LCM should be this. Okay. Now maximum power of 3 can be 4, maximum power of 7 can be 3. Correct? So 3 can take which powers? 3 can be either 3 to the power 0 can be there, 1 will be there, 2 will be there, 3 will be there, 4 will be there. Okay. LCM you want should be 3 to the power 4. Correct? LCM you want should be 3 to the power 4 and 7 to the power of 3. Suppose for example like this, 3 to the power A and 3 to the power B and 7 to the power B. Correct? Now suppose there are, for example, let's say there is this number 3 to the power 4 is there and 3 to the power 14 is there and 7 to the power 6 is there, and another number is 3 to the power 7 and 7 to the power let's say 5. The LCM if you want to take will become 3 to the power of 7 and 7 to the power of 5 in this case. Correct? That is what it is asking. It is very important to understand the question right here. Right? It is very important to understand the question right here. Now maximum, suppose you have 3 to the power of A1, 7 to the power of B1 over here, and here you have 3 to the power A2 multiplied with 7 to the power of B2. Now maximum of A1 and A2. If we ask about the maximum of A1 and A2, what can be the maximum of A1 and A2? The maximum of A1 and A2 can only be equal to 4 because in LCM we need 3 to the power of 4. Maximum of A1 and A2 can be 4. Similarly, maximum of B1 and B2, if I ask you, maximum of B1 and B2, what can this be? Maximum of B1 and B2 can be 3. Okay. Maximum of B1, B2 can be 3. Now, what can be the cases for A1, A2? Right. If suppose for A1, A2 we are counting. Now, A1 can be equal to 4 and A2 can be 0. A1 can be equal to 4 and A2 can be 0. 4 and 0. 4 and 1. A1 is 4, A2 is 1. Then also LCM will be 3 to the power 4. Right. A1 is 4, A2 is 2. A1 is 4, A2 is 3. A1 is 4, A2 is also 4. Then also LCM will be 4. 3 to the power 4. What else can be the case? A1 is 0, A2 is 4. A1 is 1, A2 is 4. A1 is 2, A2 is 4. A1 is 3, A2 is 4. A1 is 4. This case is already counted. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 ways are there. Total 9 ways are there in which you can do it. Now for 7 to the power 3, for B1, B2. B1, B2. What should be the maximum? Maximum should be 3. So A1 is 3, B1 is 3, B2 is 0. B1 is 3, B2 is 1. B1 is 3, B2 is 2. B1 is 3, B2 is also 3. Or 0, 3, 1, 3, 2, 3. So 4 plus 3, 7. That means this has 7 ways. Now what are we doing? We are doing both the things simultaneously, one after the other. Correct? 9 ways here, 7 ways here. 9 ways to create 3 to the power 4 and 7 ways to create 7 to the power 3. Both we have to do one after the another. So total ways, total number of ways will just get multiplied. 9 multiplied with 7, that means equals 63. For attempt 2, if you are going, permutation combinations is going to be really very important, right? Adityan, you didn't tell me till now. Was that the question or something else you were aspiring to ask? Okay, leave it. Right? 63 ways total. Why? Because see, you want to make 3 to the power 4 and 7 to the power 3 in multiplication. So maximum A1 and A2, that means 3 to the power, these two numbers will be there suppose, and you want the LCM of these to be 3 to the power 4 and 7 to the power 3. LCM if you want to choose, A1 and A2 highest should be 4. Right? Suppose A1 is 3 to the power 1 and A2 is 3 to the power 4. then LCM will be 3 to the power 4. Correct? That way you have to choose. That way you have to make. So total 63 ways are going to be there. Right? Let's see one more question. Now, some different type of questions when constraint is going to be there. For example, this question: how many letter words can be formed jumbling the letters of triumph such that vowels are at extreme position? Vowels are at extreme positions. Which all are the vowels? I and U. I and U are vowels. I and U are vowels. Right? Only two vowels are there. In how many? Now, how many letters are there? 7. So let's say 1, 2, 3, 4, 5, and 6 and 7. Right? Now it is saying such that vowels are at extreme position. That means this is a position of vowel, vowel 1 and vowel 2. Right? Two vowels are there, no? Vowel 1 and vowel 2. Sir, your video is blur. Okay, let me check once again. Check now. Now it should be better. Now it should be better. Alright. Vowels are at extreme position. Vowel 1 and vowel 2. Vowels, we have fixed only two vowels we have. Remaining 7 letter words that can be formed jumbling the letters of triumph. How many different? All letters are different in triumph. T, R, I, U, M, P, H. Yes, 7 letters are there. So here also for remaining 5 ones, how many options we have? 5 into 4 into 3 multiplied with 2 multiplied with 1. Remaining 5 letters will be arranged in 120 ways. Right? Right. Now vowel 1 and vowel 2. These two also, either here vowel 1 will come or there vowel will come. Vowel 1 will come, or we can think like this: we are arranging vowel 1 and vowel 2, things in two places. That means 2 factorials. So this multiplied with 2, that means 240 ways are there in which we can arrange और सर आवाज का वो उसका नेट का प्रॉब्लम ही आ रहा है, नेट का प्रॉब्लम ही आ रहा है, वो अटक ही रहा है. हाँ and I are the vowels. 3 places we have to arrange 2 things. Just think like this. Suppose we have 2 books only, maths and physics only. 2 books we have, but we have to arrange in 3 places. How will we do this task? First, we'll have to choose one of the shelf which is going to be empty. Out of the 3, which shelf can be empty? Either this shelf can be empty, this shelf can be empty, or this shelf can be empty. So 3 ways to keep a shelf empty, and then 2 into 1 ways to arrange the remaining 2 in the remaining 2 places. Same thing we are going to do over here, right? One place we have to choose one place out of the 3 which will be without the vowels. So 3 ways to choose one place without the vowels which will not have vowel. Right, from E and I, 3 odd places are there, 1 place, 3rd place or 5th place, 2 vowels are there. So 1 will remain empty, no? So there are 3 ways to choose that without vowel out of 1, 3, 5. Now arranging 2 vowels will give us 2 ways, 3 into 2. Remaining which words? Remaining, now how many words we have arranged till now? 2 vowels only we have arranged, right? Only 2 vowels we have arranged till now. Remaining how many words are there going to be? There is going to be D, L and H. So 3 into 2. Is this correct? Just think about it. Is this correct way to do it? Is this the correct way to do this problem? That's what I'm asking. Or we have made some mistake? Come on, if you are really understanding. Correct? There is no mistake. Simple. 6 into 6, that means 36. You have to understand very carefully about this problem. First, we chose an empty place which will be without the vowel, right? 3 vowels are there. 2 only we have to arrange. We have to arrange 2 vowels in 3 places. So 1 place will remain empty. To keep that place empty, 3 ways. 2 ways to arrange the vowels internally. Correct. Now, how to arrange the remaining 3 letters? 3 into 2 into 1. That means total will be 36. There will be total 36 ways in which we can do this arrangement. Method 2, 5 places can be represented by the boxes. Then 2 vowels can take position 1, 3 or 3, 5 or 1, 5. This way also you can think that there are 3 choices, 1, 3, 3, 5 or 1, 5 for the vowels to be arranged. So 3 choices and internal arrangement of vowels, that means 2. 3 into 2, and remaining letters 3 into 2 into 1. It's just about how you want to think, how you want to approach over counting. Let's see some more. How many 4 letters words containing S can be formed using the letters of the word discover? All letters are different. First we have to check that. It's very important. Problems will come ahead of it where we will consider the repeated letters. Okay, how to do that? That I'll tell you. But when all letters are different, no problem. So how many? 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, 8 places. Now, how many 4-lettered words? But we have to make only 4-lettered word. 1, 2, 3, 4. 4-lettered word starting or containing S. Not starting, containing S. S should be there. Right? S can be at the 1st place, 2nd place, 3rd place or 4th place. 4 ways are there in which I can place S inside this word. Inside this 4-lettered word. 1st place, 2nd place, 3rd place, 4th place. 4 ways are there in which I can place S in this word. Now remaining 3. One S is already placed. Now remaining 3 places are going to be filled with what? S is already placed. 8 letters were there. 8 letters were there. Now what is remaining? Out of 8, S is already placed. Remaining will be 7. Now 2 questions are there, A and B. Let's say we are doing A. Repetition is not allowed. Repetition is not allowed. When S has already been placed, one of the 4 places contains S. Apart from S, how many letters do we have? 7 letters. But now repetition is not allowed. So for the remaining 3 places, one of the places is filled. For the remaining 3 places, 3 ways. Sorry, not 3 ways, right? 7 ways, then 1 letter is placed, 6, then 5. 7 into 6 into 5 into 4. Why? Because repetition is not allowed. In 4 ways, we chose a place for S. 7 into 6 into 5 for arranging 7 letters in 3 different places without repetition. So this will be your answer. The 120 into 7. 840, I think, right? And option number B. Repetition is allowed. So 4 for your S. S should be there. S should be definitely there. Right? When S has already been placed, in 4 ways we can place S. Now for the remaining 3, because repetition is allowed, all 8 choices will be valid. All 8. S can also come. It can be SS. Right? So 4 multiplied with 8 to the power of 3. This will be your answer for the B part. Okay. For the first part, you have 4 ways remaining 3 empty. 7, 6. Correct only, no? Yeah. Okay. This is clear. 7 into 6 into 5 multiplied with 4 for the first one, and for the second part they have not written. For the total number of words, okay, total number of words minus those which are, okay, so one more method it is saying that total number of letters which can be made using 8. So there will be 8 into 7 into 6 into 5. If repetition is allowed, then 8 into 8 into 8 into 8, right, subtracted by those letters which do not contain S. So for that, 7 into 6 into 5 into 4. If we'll do this, this will also give us the answers about the letters, about the words which are containing S. These are the words which are containing S. These are the total number of words which can be formed using 8 letters. And these are the words which are formed using 7 letters, because these do not contain S. 4-lettered words which do not contain S. So these will be the 4-lettered words which do not contain. Total words minus the words which contain S. Kind of similar only. Yes. So I hope this one is also clear for you. Just give me a minute. Just a minute. Let me take a call, please. All right. Yeah, let me put this on airplane only, otherwise this will keep on ringing. All right, this is clear. Total words which have S. Now, for the other one, 4 multiplied with 7 multiplied with 6 multiplied with 5. Right? 4 for leaving S. What was the B part? What was the B part that we had? B part is repetition is allowed. If repetition is allowed, then there is no problem only. Right? If repetition is allowed, simply 8 to the power of 4. Right? 8 to the power of 4. What is it saying? How many 4-letter words containing S can be formed using the letters of the word discover? So simply you can do like this: 4 multiplied with 8 multiplied with 8 multiplied with 8. This is what we did. Containing S, that means S has to be included. S has to be included, and for S we have chosen one out of the 4 places. Any one out of the 4 places. So to do that, we have 4 ways. And for the remaining 8 letters, now letters can repeat. Repetition is allowed. So 8 into 8 into 8 multiplied with 4 will be your correct answer. One more way of thinking is that all the letters, which total number of letters using 8 digits, 4 digit word using 8 letters can be made by 8 into 8 into 8 into 8, because repetition is allowed. Right? 4-lettered word using 8 letters will be this. These will be the total minus those words which do not contain S, will be 7 into 7 into 7 into 7, because they do not contain S. So this way also we'll get all the words which contain S. 8 to the power 4 minus 7 to the power 4 will give us the answer for all the letters which do contain S. Okay. Any doubt till here? This will be the correct way. Any problem in this way? Any problem in this particular method where we are doing 4 multiplied with 8 to the power 3? Right? We are choosing one place for S. But S can be in any of the 4 places now, right? S can be in any of the 4 places. Here. S can come in any of the 4 places. So you chose one place for S. This one. Suppose here is S. For the remaining, how many choices do you have? Right? How many choices do you have? 8. So 8 over here. Right? When repetition is allowed. When repetition is going to be allowed. Next question. There are 5 questions, each having 3 options. In how many ways they can be attempted such that no 2 consecutive questions are marked with the same option? No 2 consecutive questions are marked with the same options. Think about it now. Try to solve this on your own once. But there are 5 questions, right? Just think like a simple problem. There are 5 questions. Question number 2, 3, question 4 and question 5. There are 5 different questions that we have. Now, if each having 3 options, each one is having 3 options, in how many ways can they can be attempted such that no 2 consecutive questions are marked with same options? Now, for the first question, let's say 3 choices A, B, C, right? Suppose you chose the first question. For first question, you have 3 ways to answer. Now, but for the second question, suppose you have chosen A over here, you cannot choose A over here. So for this one, you have 2 choices. Correct? If you have chosen A over here, then you cannot choose A over here. If you have chosen B over here, then you cannot choose B over here. If you have chosen C, then you cannot choose C. So except the choice you made over here, you have just 2 choices. Right? Either B and C will come. So 2. Right? Number of ways to do the second question is 2 ways. Now for the third question, no 2 questions are marked with the same option. In the third question, now suppose A you chose in the first one, B and C you chose over here. Now you cannot choose B or C. Suppose from question 1 you chose A and question 2 you chose B over there. Now you cannot choose B, you can choose A and C. So for this one also 2 choices only, no? Suppose some choice you made over here, in the next question you cannot make the same choice, remaining 2 choices you can make same thing over here. So 3 multiplied with 2 multiplied with 2 multiplied with 2 multiplied with 2 will be your answer. Right? This is how you have to think, this is how you have to solve. Hi Abhinav, how are you? All right, clear? Next, a flag is to be colored in 4 stripes by using 6 different colors, no consecutive stripes being of the same color. This can be done in how many ways? Simple question, come on, give me the answer for this one. Of 6 different colors, right? No 2 consecutive stripes being of same color. First stripe, whatever color you chose, in the second strip you cannot choose that. So 5 ways for the second strip. Now for the third strip, whatever you chose over here, that you cannot choose. Remaining all 5 you can choose. Suppose you have 6 colors: white, green, yellow, blue, red and violet. Suppose for first one you have all the 6 choices. Suppose in the first stripe you chose white. For the second stripe you will have 5 choices. Now in the second stripe, suppose you chose blue. For the third stripe, again, except blue, you will have all the 5 choices, right? Same over here, same over here. This should be your answer. 5 to the power 4 multiplied with 6. No, 4 colored in 4 stripes. So 5 to the power 3, 125 multiplied with 6. I think 750. 125 multiplied with 6 will give you 750. This easily you can think, if you just think like number of ways, counting the number of ways. How many 4-digit numbers can be formed using 1, 2, 3? 1, 2 and 3, 4-digit numbers. 4-digit numbers using 1, 2 and 3. मौलिक सर वो गई, कौन गई? Okay. 4-digit numbers using 1, 2 and 3, right? For first place, repetition, not repetition. If it is not required to be mentioned that repetition of digits is allowed, it's not required to be mentioned. If it is not mentioned, we have to assume that repetition is allowed. So obviously for the first place we have 3 choices, second place 3 choices, here also 3 choices, here also 3 choices. We are going to do all of the same, all of them, one after the other. So 3 to the power 4. प्यार प्यार ना रहा मौलिक, प्यार के चक्कर में ना बाद में प्यार मिलना मुश्किल हो जाएगा थोड़ा. चलिए, let's do this advanced 2018 problem. Number of 5-digit numbers which are divisible by 4 with digits from the set 1, 2, 3, 4, 5 and the repetition of digit is allowed. Come on, try this. Just for information, for divisibility by 4 means last 2 digits should be divisible by 4. Divisibility by 4 means last 2 digits should be divisible by 4. Okay, last 2 digits should be divisible by 4. 1, 2, 3, 4, 5. So these 2 digits should be divisible by 4. So what all options do we have over here? 12 can come first, right? Then 1, 2, 1, 3, 1, 4, 1, 5, nothing. 2, 1, no. 2, 3, no. 2, 4, yes. 2, 5, no. Then 3, 1, no. 3, 2. 8 4s are 32. Yeah, 3 2 is also allowed. 3 4 no. 3 5 no. 4 1 no. 4 2 no. 4 3 no. 4 5 no. 5 1 no. 5 2 yes. 5 2 can also be there. What else? 4 4 can be there. 4 4 can be there. 1 1 2 2 3 3 4 4. Yes, these are the options that we have for the last 2 places. And the repetition of digits is allowed. So for this one, for these 2 places, we have 1, 2, 3, 4 and 5 options, right? Now for remaining 2 we have chosen. For remaining, repetition is allowed, no problem, right? For these 2 places only 5 options are there. For remaining 3 places, any 5 into 5 into 5, any 5 we can choose, right? Any 5. So answer will be 5 to the power of 4. This will be your answer. 625 will be your answer. Understood, right? Just think how many ways you have for filling up the places. That's it. That simple the question will become. Okay. How many 3-digit numbers less than 600 are and divisible by 5 can be formed using these digits? Less than 600 and divisible by 5. For divisibility by 5, last digit should be either 0 or 5. How many 3-digit numbers? We have to make 3-digit numbers. So last digit can be 0 or 5. So only 2 choices for this one. For divisible by 5, no. So only 2 choices for last digit. Now repetition of digits not allowed. So 1 we have already chosen. From 0 and 5, 1 we have already chosen. Acha, we want to make a 3-digit number. So first place cannot be 0. First place cannot be 0. What else can it be? 1, 2, 3, 4, 5 or 9. So 6 choices for this place. And 5 choices for this place. Correct? Or not 5 choices, not 5 choices. See, in first place, we total numbers are 7. Right? Total numbers which we have over here are 7. But for the first place, which cannot be 0, we have only 6 options. So 6 ways to fill it up over here. For this one now, 0 can be there in the second place. So here also 6 options. 6 options. 1 we have already used. Don't think I'm repeating. 1 we have already used. But 0 we could not use over here. That's why 6. But in the second place we can use 6 also. 0 also. So 6 multiplied with 6 multiplied with 2. 2. Why? Because 0, either it will be 0 or it will be 5. Is there anything wrong in what we have done? Just think about it. Anything wrong? Yes, no, wrong. Why? Because see, first you think, first you chose this place, so 0 or 5, right? Two choices over here, two choices. How many numbers you would have placed over here? One number you have already placed over here, because repetition is not allowed now. So one number you have already placed. So what you'll do, you'll make two cases now. Case number 1 you'll make where last digit is 0, and case number 2 you'll make where last digit is 5. This is 0 and let's say this is 5. Okay, either this or this, either this will be the case or this will be the case. Two different things. Now case 1 where last digit is 0, remaining are 6 digits are remaining. So here, because 0 is already placed, so here 6 multiplied with 5, repetition is not allowed. Here 5 is already placed, first place cannot be 0. So for it, how many? No, not 6, wait. 0 is already placed. How many remaining digits? 6 multiplied with one digit already placed over here, so 5. Repetition is not allowed. Okay, 0 multiplied with 0 means 1. 0 already placed, no, one way to place 0. Now 5 is already placed, right? So one way to place 5 is the last digit and here 0 is the last digit. 1 is already placed. First digit, what can it be? It cannot be 1, it cannot be 0. What are the remaining options? 5 options. First digit cannot be 1 because repetition is not allowed. 0 because 3-digit number we want. So 5 multiplied with what? Second digit, it cannot be 1 and it cannot be one of the digits which is chosen over here. So remaining how much? 0 total are 4, 5, 6, 7. 7, 1 it cannot be over here also. So 5 choices. It can be 0. It can be 0, but it cannot be the number which we have chosen over here. So this will give us 30 cases. This will give us 25 cases. Total will become 30 plus 25. Why? Because either this in this case it is possible, or in this case it is also possible. So total number of possibility will be 55 ways. Total number of ways to do this will be 55. This is less than 600. We didn't include this. Wait. We didn't include this. We did not include this case. Less than 600, we didn't think about it till now. Our answer is just the total number of possibilities where the number is divisible by 5. 3-digit number which is divisible by 5 is 55 numbers are there. But if it has to be less than 600, then again we'll have to think in two cases. Now last digit, again think like this. Last digit 0, that means one way. Now it should be less than 600. So for the first place, what all options you have? 1, 2, 3, 4 and 5. It cannot be 6. It cannot be 6. Less than 600, no. So 5 choices for the first place. 1, 2, 3, 4 or 5. 0 cannot come here. For the second one, anything can come. Anything can come except 1 and except the number which we have chosen over here. So except 2 out of 7. 2 are gone, so 5. So 25 ways are coming here. Now for this one, 5 is kept at the last place. One way is already done. Number should be less than 600. So either here what can come? 1 can come, 2 can come, 3 can come, or 4 can come. 5 cannot come. 5 we have already occupied. So 1, 2, 3, 4. That means 4 ways. For this one, what all can come? 0 can come. Right? Anything can come except these two. So 5 ways. Except these two. So 20 over here. So answer in this case will become 45. 20 plus 25. In this case, the answer will become 45. 4, 5, 45. Alright. When repetition is not allowed. Now, when repetition of digit is allowed, again, same thing. So case 1, where we are including last digit as 0. So one way to keep 0 in the last place. One way to keep 0 in the last place. Now, here, what all can come? 0 is already taken. So remaining 6 digits. But we want to keep it less than 600. So 1, 2, 3, 4 and 5. Right? 1, 2, 3, 4 and 5. 1 can come, 2 can come, 3 can come, 4 can come, 5 can come. Okay. Now 0 has already taken and repetition of digits is allowed. Repetition is allowed. Correct? This can be 1, 2, 3, 4 or 5. 0 it cannot be. This cannot be 0. Repetition is allowed. Still 0 we cannot fill over here. Now for this one, how many choices we have? Either 1 can come, 2 can come. So anything can come except these two. Except these two, no. Repetition is allowed. So now anything can come. 0 to 9, anything can come because digits can be repeated. So 9 choices for this one. So 9 choices for this one. How many? Sorry, not 9. 4, 5, 6, 7. 7 numbers only we have. No, so 7 choices for this one. Case number 2, where we are including 5. Right, last digit 5 already. For the first digit, it should be less than 600. So 1, 2, 3, 4 and 5 all can come. All can come. 5 choices we have over here. For this one, again, anything from 0 to 7, anything can come. 0 to 9, anything can come. So all 7. All 7. Right? So just multiply 2 with 35. 7 5s are 35. That means total 70 ways are going to be there. That means total 70 ways are going to be there with us over here. Alright, let's move ahead. Let's see some more questions. Although we don't use it, but yeah, sometimes if you have either or, neither nor, then you should use like this. Then it always try using this. It's saying either or. This is for the case either or. This is for neither nor. Right? Either or, neither nor. Now, either or means either A or B. That means number of elements in A union number of elements in B. This we have studied in sets also. Will be equal to number of elements in A plus number of elements in B minus the number of elements in A intersection B. Here, if you want neither nor, then number of elements in A complement intersection B complement. That means total minus number of elements in A union B. If you don't, neither nor means total minus number of elements in A union B. That's it. Okay, how many 5-digit numbers can be formed? Can be formed which either begin with 2 or end with 5. Either begin with 2 or end with 5. Right? Either they should begin with 2 or they should end with 5. So 5-digit numbers 1, 2, 3, 4, 5. Just try doing it with the help of cases. Either or, simply just understand first case, which is begin with 2. Let's say this is begin with 2. Let's say this is begin with 2. So 2 is already fixed over here. That means 1. One way to keep 2 over here. Right? 5-digit numbers can be formed. So repetition is allowed definitely. Why? Because it's not written anything. So we'll assume that repetition is allowed. So 10 into 10 into 10 into 10. First digit is already 2, so we don't need to worry about 0. Right? Now end with 5. Second case is end with 5. So one way to keep 5 over here. Now here 9 ways. For the first digit only 9 ways. Because we cannot keep 0. Right? So 9 ways to fill up the first place. Rest same. 10 into 10 into 10. Now because it's written how many either or case. Either or case means this is suppose your A set. This is number of elements in set A. This is your number of elements in set B. What do you want? Either or. Either or, what did I say? N of A union B. That means number of elements in A union B, which will be equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Now this if we add both of them, suppose if we add n of A plus n of B, right, what will we have? In this we have those numbers also which are ending with 5. In this we have those numbers also which are ending with 5. And in this we have those numbers also which are starting with 2. Correct? So we have to, because we have added them, because we have included them 2 times, we have to subtract them once. That means we have to subtract those numbers which are intersection of A and B. That means starting with 2 and ending with 5. Starting 2 and end with 5. We'll have to remove those cases. That's what it means. If you don't want to remember this formula also or this thing also, then also understand it like this. Begin with 2, either begin with 2 or end with 5. We have included those numbers which are beginning with 2 and ending with 5. Both the things. Either it should begin with 2 or it should end with 5. It should not include the numbers which are beginning with 2 and also ending with 5. So numbers which will be beginning with 2 and ending with 5 will be how many? Beginning with 2, one way. Ending with 5, one way. For the middle ones, beginning with 2 will be kept here only in one way, 5 will be kept here only in one way. Remaining 3, how many choices we have? All the 10. 10 multiplied with 10 multiplied with 10. Okay, so what we'll do, this will become 10 to the power of 4 plus 9 into 10 to the power 3 minus, what will this be? 10 to the power of 3. That's it. So 10,000 plus 9,000 minus 1,000. 10,000, 9,000 minus 1,000, 18,000. Right? 18,000. This will be 18. Answer will become as 18,000. This is what this particular thing means. Remember that. Okay, either or. For example, this question, number of 4-digit numbers which are neither multiple of 7 nor multiple of 3. Neither the multiple of 7 nor the multiple of 3. So first we'll find all the 4-digit numbers. Total 4-digit numbers will be, it starts from 1000 and ends at 9999. So total 4-digit numbers. Total 4-digit numbers will be how many? How many will be total 4-digit numbers? It will be 9,000 numbers. Right? 9,999 minus 1,000. That means 8,999 plus 1. Because we have to include both of them. Both are 4-digit. Right? If you have to include both of them, that means total 9,000 numbers will be there. Arbai, from 1 to 9, how many numbers do you have? If you want to include 1 and 9 both, 9 minus 1 plus 1. Right? That will be 9 minus 1 plus 1. If you want to include 9 and 1 both, then total will be 9 numbers including 1 and 9. If you don't want to include any one of them, then 9 minus 1 will give you 8. Where 8 is not including either 1 or 9. Okay, so total 9,000 numbers are going to be there. Okay, now what you have to do, total numbers, 4-digit numbers which are neither multiple of 7 nor multiple of 3. If you want to solve, you can solve it with AP also. This is actually question of sets, not of permutation combinations. Total 4-digit numbers which are neither multiple of 7 nor multiple of 3. So for 7 we don't have such easy divisibility test. That's why we'll have to use AP over here. Find the first 3-digit number. Okay, try doing this. JEE Mains 2021. Multiple of 3. See, first multiple of 3. Let's say A are multiple of 3. A are multiple of 3. B are the multiple of 7. Right? And C are multiple of 7 and 3. Both. That means multiple of 21. Right? That means multiple of 21. Okay? Multiples of 7 and 3 both will be multiples of 21. What do you need to find? Neither the multiple of 7 nor the multiple of 3. That means a number of elements in A complement union B complement. Correct? This is what was given. This was given. This is what gave over here. So total minus number of elements which are multiple of 3 and number of elements which are multiple of 7. That's it. Total are 9,000. Right? If we talk about multiples of 3, so multiple of 3 starts from 1002, right? Then 1005, 3 3 are 9, 10, 3 3 are 9, 1 2, right? 105, these are multiples of 3. Last multiple of 3 will be 9,999 only, right? These are multiples of 3, right? Similarly, multiples of 7. So first multiple of 7 that you will have will be 1001. Right, 1001. Then next will be 1008, 1001, right? 130, 28, 21, yeah, right? And last multiple of 7 you'll have to find out. I think 9996 it will be. Yes, 9996 it will be. Similarly for 21 also you'll have to do that. A intersection B, this is what? This is what? Number of elements in A plus number of elements in B minus number of elements in A intersection B. That is the formula. Remember, this is the formula, right? Number of elements total, or you can write this as total also, same thing, right? Total minus number of elements in A intersection B. That means intersection B means this is your A intersection B. This is your A intersection B. That means multiples of 21, which are multiple of 7 as well as multiple of 3 both. Right? So multiple of 7 will be what? They'll start from 1008. This started from 1008. 1008 will be the first multiple of 21. 21 fours are 84. 16, 168. 21 into 8. 8, 16. Yeah. Right. 1008 will be the first multiple. And last multiple will be same as 9996 only. No, this will be your last multiple. So from here you can find the multiples of 3, then multiples of 7 minus the multiples of 21. That's what you'll have to do. So total multiples of 3 you'll find, right? Simple, apply AP. No, 9999 is equal to A, that means 1002 plus n minus 1 into D. What will be D? D will be 3. D will be 3. Correct? So from here you'll find n. How much n will come? 8007 by 3. 8007 by 3. Just let me 8007 by 3 plus 1. So 3206 620 1820 1827 27 2669. Right? Total from here n will come 2669. That means 2670 plus 1. That means 2670. N will be 2670. Similarly, you can find this, right? 9996 will be equal to 1001 plus n minus 1. Difference will be 7. So this also you can do. This will become 8995 divided by 7 plus 1. So this will become 127. This will come as n will come as 1286. Right. Similarly, you can find for 21 also. D will become 21 and n will come as 9996 minus 1008 divided by 21. Okay. So that's it. This much only you have to do. Pyar na raha. My God. Okay, this much you have to do. All the multiples of 4, all the multiples of 7, all the multiples of 3 you'll find first, then 7, and then 7 and 3 both, because the multiples of 21 are the multiples of 7 as well as 3, right? And when you are counting the multiple of 7, multiples of 21 are also coming. When you are counting multiple of 3, multiples of 21 are also coming. So you'll have to subtract that. Okay, ji. Can you tell me what will be the multiples of 21? How many will be the multiples of 21? How many multiples of 21 we are going to get? This is 1286. Multiple of 21, 20. So this will be 8992 divided by 21. 8992 divided by 21. That means 429. Right, this will be equal to 429. So your answer will become nothing but multiples of 7 plus multiples of 3 minus multiples of 21. 2670 plus 1286 minus 429. That will be your answer. Right, your answer will be 9000 total minus 2670 plus 1286 minus this 429. So these will be the multiples which are of 3, 7 or both. Right, 3, 7 or both. From 9000, if we subtract this, our answer will be obtained. Answer should be equal to 5143. Just check your answer once. Okay, this question came this year. From all English alphabets, 5 letters are chosen and are arranged in alphabetical order. The total number of ways in which middle letter is M. 5 letters are chosen. Middle letter is M. Okay, this is what it is saying. 5 letters are chosen and arranged in alphabetical order. Now, middle letter is M and these 5 letters are arranged in alphabetical order. Okay. 5 letters, all right, no problem. Now, for this portion, number of ways to choose, although we are going to do afterwards, but for this portion, letters which are greater than M, alphabetically greater than M are how many? M is your 13th letter. So after M, right, 12 letters will come. After M, how many letters will come? M is 30, M, N, O, yeah, M is 13th letter. So after M, how many letters are going to come? 13 letters are going to come. This is 30, total 26 are there. This is 13th. After this, 13 letters are going to come. From 13, we have to choose 2, any 2. From 13, we have to choose any 2. So 13 into 12. Correct? 13 into 12 should be our answer. Divided by 2. Why? Because 13 letters, 13 C2 we'll be doing, right? And for this one, what we'll be doing? We'll be remaining letters which are smaller than M. Smaller than M will be 12 letters, and from 12 we'll be choosing any 2, right? We'll be choosing any 2. That will be your answer. Just 12C2 multiplied with 13C2. Actually, this question should come after selection. But number of ways to select R objects from N different objects. Number of ways to select R from N will be NCR. That's it. NCR. That's it. 13C2 means from 13 objects we are selecting any 2. From 12 objects we are selecting any 2. That's it. And the formula you know, right? 13C2 will become 12 factorial divided by 12 minus 2, that means 10 factorial multiplied with 2 factorial. That will give you 12 multiplied with 11 divided by 2. That means 66. 10 factorial will get cancelled. Right? So this will become your 66 and your 13C2, that means 13 factorial divided by 11 factorial multiplied with 2 factorial. So this will be 13 into 12 divided by 2. This will become 13 multiplied with 12 divided by 2. That means this is going to become 13 into 6. That means 78. So this will become 78. So total number of ways will be just 66 multiplied with 78. This will be your answer. 66 multiplied with 78. Just check. I think last digit also, if we check, 48. Last digit 8 is only in 5148. So 5148 will be our correct answer. That's it. So when choosing smaller letter, example, if B comes before A, then it won't be in alphabetical order. No, B cannot come before A, na? B cannot come before A. Acha, I got your point. You mean to say that suppose when we are choosing from 12 letters, we are choosing any 2. What if B comes before A? That way you are saying? Right? Is that what you are saying? But beta, when we are applying this NCR, from 12 we are choosing any 2. When we'll be choosing in order, right? When we'll be choosing, we'll choose in order only. From these 12, if we are choosing anything, we'll be choosing in order only. Definitely. Yeah. When we apply 12C2, we apply it in order, na? First to second 2, third 2, fourth 2, fifth 2, like that. First and third, first and fourth, like that. So 12C2 will be applied like this. We'll be choosing in order only. Anything else? Actually, this should come in selection, but this question came earlier. No problem. All right. We'll be choosing in order only. When we apply 12C2, we are choosing in order, right? Any two letters if we are choosing, we'll be choosing in order only. Okay, give me a minute. I'll just be back. All right. Yeah, Heisenberg was saying, sir, sir, is anyone playing piano? Yeah, somebody, there is some noise. That's what I went to check. Heisenberg, you were saying, no, how we choose? Suppose P1, P2, P3, P4 and P5. We have 5 pens. Then from 5, if you want to choose 2, we'll write it as 5C2. Right? So what we can do, P1 and P2 we can choose, P1 and P3 we can choose, P1 and P4 we can choose, P1 and P5 we can choose. Now when we'll start with P2, P2, P1 will not include. Right? P2, P1 is going to be same. Similar, P2, P3 will be new. P2, P4 will be new. P2, P5 will be new. Correct? Right? Remember this method. If you then again from P3, if you are choosing P3, P1, P3, P2, P3, P4 and P3, P5. Correct? Two different we are choosing, right? Or suppose we are then P4, P1, P4, P2, P4, P3, P4, P5. Similarly for P5. Right? Now repeated cases will be cancelled. So P1, P1, P2 is there, P2, P1 will be cancelled. P1, P3 is there, then P3, P1 will be cancelled. P1, P4 is there, so P4, P1 will be cancelled. P1, P5 is there, so P5, P1 will be cancelled. Right? Similarly, P2, P3 is there, so P3, P2 will be cancelled. P2, P4 is there, so P4, P2 will be cancelled. P2, P5 is there, so P5, P2 will be cancelled. Similarly, P3, P4 is there, P4, P3 will be cancelled. P3, P5 is there, P5, P3 will be cancelled. Correct? Anything else which is repeating? P5, P4, P4, P5, P4, P5, P4, P5, P4, P5. Yes, P5, P4 will be cancelled. Any other repeating case? No, I don't think so. Now count. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Correct? What is 5C2? 5C2 is what? 5 factorial divided by 2 factorial multiplied with 3 factorial. Correct? That means 5 into 4 divided by 2 factorial. That means this is also 10. 5C2 will always choose in order P1, P2, P1, P3, P1, P4, P1, P5, P4, P5, P2, P5, P2, P4, P2, P3, P3, P4, P3, P5. Very important concept this is. But in permutation, we consider P1, P2 and P2, P1 as different. Now, in permutation, arrangement, it is different. Selection we are doing. In combination, in selection, when we are applying 5C2, that means any 2 from these 5, we are choosing in order. We are choosing in order. P1, P2 and P2, P1 is the same selection. Getting my point? So that is why here you don't have to worry about, sir, whether are we choosing these in alphabetical order. Yes, we are choosing them in alphabetical order. When we are doing 12C2, we are actually choosing them in alphabetical order only. When we are applying 13C2, we are doing it in alphabetical order only. Now, am I clear? Now am I making it clear? Because if you apply at a simple, smaller problem, like this, from 5 if we are choosing 2, when we are doing this, we are getting all the ordered pairs in order only, right? In order only. Correct? So when this selection of NCR is an ordered selection, remember that. Very important thing. Okay, ji. Let's go ahead. Number of ways of arranging R distinct objects in R places is R factorial. R places R objects. Number of ways of arrangement is R factorial. Number of ways of selecting R objects out of N distinct objects. Out of N distinct objects, in how many ways can you choose R objects? The number of ways will be NCR. Right? Suppose choosing 2 girls out of 7, so 7C2. Out of 7 different girls, if you want to choose 2 girls. If you out of 7 different boys, if you want to choose 2 boys, 7C2. Right? It will be ordered selection. B1, B3, B1, B4, B2, B3, B4, B2, B4, B2, B5, B4, B5, like that. Got my point? It will be an ordered selection. Don't worry about the order. Now let's do some questions based on this. Selection. Now let's do some questions based on selection. For example, over here, a committee has of 6 to be formed out of 8 men and 5 women. In how many ways can this be done when 2 men and 4 women are included? 2 men, that means out of 8 we have to choose any 2. 4 women, that means out of 5 you have to choose any 4. Both the works you have to do simultaneously. You have to choose 2 men and 1 woman. This will be multiplied. That's it. 8C2 multiplied with 5C4. At least 3 women are included. At least 3 women. At least 3 are included. So how many women are there? 5 women there. Either 3 women, 4 women or 5 women. Group of 6 has to be formed. When 3 women are included, out of 5 women, you have to choose 3. 5C3 and remaining 3 people. Total group is of 6. 3 are already taken. 3 women are there. Remaining are 3 people. So out of 8 men, you have to choose the remaining 3 people. Right? If you want to choose 4 women, at least 3 women, na? So case 1, this will be your case 1, that you are choosing 3. This will be your case 2. Sometimes you'll have to make cases. So let's say case 3, when there will be 5 women. Right? More than 5 is not possible only because 5 women are only there. Now suppose you are choosing 4 women. So out of 5 women, you have chosen 4 women and remaining 2 people. 4 are chosen. Remaining 2 people out of 6 will be chosen from boys. 8C2. 5 women, that means 5C5. All women, selecting all women, there will be one way only. So 5C5 is 1. Right? Multiplied with remaining people, how many people will be remaining? 1 person will be remaining. So from 8 men, 1 man, you have to choose. That's it. So total sum of all this will be there when you are choosing at least. Either at least 3 can be achieved by doing either this or this or this. So sum 5C3 into 8C3 plus 5C4 into 8C2 plus 1 into 8 plus 8. This is 1 and 8. Okay, that will be your answer. That will give you 708. 5C3 into 8C3, 5C4 into 8C2, 5C5 into 8C1. Alright, let's go ahead. At most 3 women. At most 3 women. That means either 3 women, 2 women, 1 woman or 0 women. At most means 0 can also be included. At most 3 women. So this will be 8C3 into 8C3. Sorry, 5C3 multiplied with 8C3. 3 women. For 2 women, 5C2 multiplied with 8C4. Right, 2 women you have chosen. 1 woman, that means 5C1 multiplied with 8C5. And this will mean 0 women. There is only one way of selecting 0 women, and remaining all the 6 men, all the 6 people you are choosing from the men. Clear? 5C0 will be 1 only, right? 5C0. Selecting 0 women will be 5C0. So that will be 1 only. 1 multiplied with 8C6. 8C6 will be 28. Right? Clear? Right? Sum of all this. Sum of all this. Obviously. Sum of all this will be your answer. Sum of all these will be your answer. Call my name. My God, Mukesh. Hi, Mukesh. Are you the same Mukesh which we see in the advertisements? No? Other Mukesh? Right. Alright. JEE Main 2020. Very simple question. Look, there are 3 sections in a question paper and each section contains 5 questions. A candidate has to answer a total of 5 questions, choosing at least 1 question from each section. The number of ways in which the candidate can choose the question is. Come on, give it a try. Very easily it can be done. 3 sections are there. Each section has 5 questions. Come on. A candidate has to answer a total of 5 questions, choosing at least 1 question from each section. Three sections are there, right? Section 1, section 2, section 3, right? 3 questions, 1, 2, 3. This also has 1, 2, 3, 3 questions. This also has 1, 2, 3, 3 questions. Okay, what he has to do, candidate has to answer a total of 5 questions. Total 5 questions he has to answer, choosing at least 1 question from each section. At least 1. So either 1 from this, 2 from this, or 3 from this. Then only he can choose, right? So suppose from section 1 he is choosing either 1 question from section 1, right? Either 1 question you can choose from section 1, 2 questions you can choose, 1 question from section 1. Let me write like this: section 1, section 2, section 3, right? Either we can choose 1 question from section 1, 2 questions from section 2, 2 questions from section 3. Okay, otherwise 2 questions from section 1, 1 question from section 2, 2 questions from section 3. All right, because we have to answer 5 questions from 3 sections. Or what else we can do? We can choose 1 question from section 3, 2 questions from here, 2 questions from here. Or something else? More things we can do, right? 3 questions from section 1, 1 question from section 2, 1 question from section 3. Same thing we can do with section 3, section 2 and section 3 also. Correct? These are the possible ways. Any other way in which we can do this? Any other way in which we can attempt? Just think of those. Any other way in which we can do this? Now pay attention here. Right? This is same thing multiplied with 3. What is this? What will be this? 3 questions from section 1. Each section contains 5. So 5C3 multiplied with 3 section 1, 1 here. So 5C1 multiplied with 5C1. This is one way of doing. 5C3 multiplied with 5C1 multiplied with 5C1. Correct? And this entire thing is also same. There is no other way in which we can do 5 questions, so that one question from every section is chosen. 1 2 2 or 3 1 1. There is no other way. 1 2 1 will not make it 5. Okay, so these are, now all these are also same. From section 1, so what will be the answer for this? So this multiplied with 3. This you are doing for section A. Either from A you will choose 3 questions, or from B you will choose 3 questions, or from C you will choose 3 questions. So this plus this plus this, same thing added 3 times, so 3 into this. Correct? Plus, or this way also you can do. This way also you can do this. What is this? 2 questions from section 1, 2 questions from one section, 2 questions from another section, and 1 question from the third section. So 5C2 multiplied with 5C2 multiplied with 5C1. Correct? And same thing you can do 3 ways, like 3 times. Either from section 1, either this one you are following. So for let's say for this column we are talking. So this is 5C1 into 5C2 into 5C2. For second column also same thing will come, 5C2 into 5C1 into 5C2. For third column also same thing will come. So this same thing, either this way we can do, this way we can do, or this way we can do. So 3 into this plus 3 into this will be your total answer. So 10 into 10, 100 into 5, 500 into 3, 1500. 1500 plus this will become 5C2 and 5C3 are same only. 10 into 5 into 5, 25, 250 into 3, 750. 2255 should be the answer. 2250 should be the answer. Right? This will be 750. So 2250 will be your answer. Correct. Okay. Now, in how many ways we can select 3 numbers out of 1 to 100 such that they form an AP? AP, 3 numbers, right? A, B and C. Such that they form an AP, that means 2B is equal to A plus C. That means A and C should be sum of A and C. Right? Sum of A and C should be an even number. A plus C should give me an even number. Either the sum of 2 even numbers is even, or the sum of 2 odd numbers is even. Correct? Either the sum of 2 even numbers, even plus even, will be even always. Odd plus odd will also be always even. Right? So either we have to choose 2 even numbers, or we have to choose 2 odd numbers. In 1 to 100, how many even numbers are there? 50 even, 50 odd. Right? From 50 even numbers, any 2 I can choose, so that even plus even gives me even. Or for odd, 2 odd numbers from 50 even, 50C2. Either this way I can do this, or this way I can do this. That's it. So my answer will be 2 multiplied with 50C2. This will be my answer. Simple questions. These type of questions are asked multiple times in JEE. So remember how to do this. So AP means A plus C should be equal to 2B. That means A plus A and C should either both be even, both be odd. When both are even, then only sum will be even. When both are odd, then only sum will be odd. In 100 numbers, 50 are even. From those 50, any 2 you can choose in 50C2 ways. From the remaining odd ones also, there are 50 odd numbers. So from either 2 odd, either you can do it by choosing 2 even, or you can do it by choosing any 2 odd. So choosing any 2 even is 50C2. Choosing any 2 odd is also 50C2. Add both of them, because either we can do it this way or this way. So 2 into 50C2. Right? That's it. Now, in how many ways can a basketball team of 12 players be selected out of 18 players if 3 particular players are always to be included? Constraint. Right? 3 particular players are always to be included. They should be always included. 3 particular players. They can be anybody. Virat Kohli, Rohit Sharma, and this is basketball. Sorry, I don't even know basketball players' names. So sad, so bad. Okay. Anyway, 3 particular players are always to be included. That means these 3 are going to be there. By if your coach is partial and he is going to include 3 people already, then you tell me he'll be doing the selection out of 18 players or 15 players only, because he has already decided that 3 people I'm going to choose. So remaining selection out of 12 players, out of 12, 3 he has chosen. So now he have to choose 9. Choose 12 minus 3, that means he has to choose 9 only. He'll be choosing 9 people only. Out of how many? 3 he has already chosen out of 18. But you, what do you want? You want 12 people, 12 to be selected, 12 to be selected out of 18, right? Ways are 18C12. Okay, no problem. But 3 players are already decided. So basically, you'll be doing your selection from 15 people, right? 3 are already there. And how many you'll be selecting? You'll be selecting 12 minus 3, right? You'll be selecting 12 minus 3. 18 minus 3, C 12 minus 3. This will give you 15, C 9. So this will be your answer. From remaining 15, you have to choose 9 people, because 3 you have already selected. They are already been included. So 15C9 will be your answer. 15C9 will be 5005. If 2 players are to be excluded, I don't want these 2 players. I don't want these 2 players. These 2 players are already excluded. From how many? From 18 players, 2 are excluded. From 18, 2 excluded. From the 18 players, 2 excluded. Then from how many players am I doing the selection? And I don't want them. I don't want them. So I'll be doing my selection from 16 people. And how many I need in the team? 12. So 16C12. Because 2 I don't want only. I want to select 12 people out of 16 only. I'm selecting out of 16 only. 2 I have already rejected. 2 I have already rejected. 16C12. Very good. 1820 will be the ways. If 3 particular players are to be included and 2 particular players are to be rejected. Right? So rejected, that means 18 minus 3. 3 already included. So you are doing your selection from 15 only. And 2 are to be rejected. 2 more are rejected already. Right? 3 are selected and 2 more are rejected. So these 2 also I am not doing my selection from. Right? I am not doing my selection from. I have already selected 3 people. So I am doing my selection from 15. Already selected 3 people. I am doing my selection from 15. And from these 15 also, 2 are already rejected. So I am actually doing my selection from 13. Correct? Selecting from 18, I have rejected 2 people. Right? And already included 3 people means that these I don't have to select. Right? I have already selected them. And 2 I don't want. So minus 2, minus 3. Right? C. Now how many people I want in the team? I want 12 people. From these 12, 3 are already selected. That means I'll be doing from 9 only. And 2 I don't want. So I want 9 people. I want remaining 9. Because 3 I already have. They are already included. Right? So this will be 13C9. 13C9. My selections will be 13C9. So this you have to sanely think and do. 13C9 is 715. Okay, this is how you can do. If 2 particular players cannot come together in the team. Now think about this. 2 particular players cannot come together in the team. Very simply, complement case. Total ways, total minus when 2 are together. Total number of ways in which we can select 12 players out of 18. That means 18C12 minus when 2 are already together. When 2 are together. Number of ways in which 2 are included. That means 16C10. Correct? If 2 are included already, then I'll be doing my selection from 16 and I'll be choosing 10 people only. So if I subtract from total the number of ways in which 2 are already together, will give me the ways, that means ways in which 2 are not together. Okay. What is the solution? 18C12 minus 16C10. That means 10556 should be your answer. Alright, let's go ahead. There are 10. This question came in 2022. Let's look at the question. There are 10 boys B1, B2 till B10 and 5 girls G1, G2 till G5 in a class. Then the number of ways of forming a group consisting of 3 boys and 3 girls. If B1, B2 together should not be the members of a group. This question should come a little bit later, alright, but I'll tell you here also. 10 boys, B1 to B10, 5, the number of ways of forming a group consisting of 3 boys and 3 girls. Total number of ways in which we can form a group consisting of 3 boys and 3 girls. From 10 boys, we'll choose 3 boys. And from 5 girls, we'll choose 3 girls. So in this way, we can form a group of 6 people containing 3 boys and 3 girls. These are total number of ways. Now from total number of ways, if I subtract the ways where B1, B2 are always together, if both B1, B2 together should not be the members of the group. From total, if I subtract the cases where B1, B2 are together, remaining will be the cases where B1, B2 are not together. Now suppose B1, B2 are together. That means B1, B2 are already taken, already chosen. So from remaining 8, I'll be choosing 1. Remaining 8, 3 boys only I can choose. 2 are already taken, B1 and B2. So from remaining 8, I'll be choosing 1. Remaining 1 boy, third boy, I'll be choosing from 8. From out of 10, 2 are already chosen. 8 boys remaining, 8C, 1. Girls, 5C, 3. 3 girls I have to choose. I still have to choose 3 girls, no? So from total cases, if I subtract this, this will be my answer. That's it. This will be your answer. 1120. Yeah, actually 10C3 will become your 10 into 9 into, let's calculate, no, 10 into 9 into 8 divided by 7 factorial gone, 3 factorial, 3 into 2, 4s are 8, 3 3s are 9, multiplied with 5C3, that means 5 factorial divided by 3 factorial, so 5 into 4 divided by 2 factorial, so 5 into 2 only. Alright, so this is coming how much? 30, 4 3s are 12, 120 into 10, so 1200, right? Minus, this is coming out as 8 multiplied with 10, 80. So 1200 minus 80 gives us 1120, exactly. Okay, 1120 is the correct answer without any trouble. This question, this year only, number of words can be formed using the letters of the word daughter so that all vowels never come together. Okay, all vowels never come together. Daughter, very nice word. D-A-U-G-H-T-E-R. Which ones are the vowels? Which ones are the vowels? A, E, I, O, U. So A, E and U are the vowels. Now I want to make, what is the question? Number of words which can be made using the letters of the word daughter. How many words are, how many letters are there? 3, 3, 6 to 8. Right? 8. Such that vowels do never come together. Right? Such that vowels never come together. Vowels never come together. Now, how many words? First, I'll see how many words can I make totally using these. Right? Total minus the words in which vowels come together. If I do, remaining will be the words in which vowels are not together. So, total number of arrangements. Total number of arrangements 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial. Right? 8 factorial. Total words which I can make using the letters of the word daughter. Using all the letters of the word daughter. I have to use all the letters. That means repetition is not allowed. Using all the letters of the word. So repetition cannot be allowed. Now if you repeat anything, that means 8 factorial are the total number of ways in which I can arrange the letters of the word daughter, minus the words in which all the vowels are coming together. All vowels are coming together means what? 1, 2, 3, 4, 5, 6, right? 4, 5. Suppose all vowels are coming together, right? All the vowels, I'll make a packet of the vowels. What I do in this case, I'll make a packet of vowels. 3 vowels are there, I'll make a packet. I'll treat this packet as one word only. Oh, one letter only. So remaining out of 8, if 3 are removed, 5 will be remaining, and remaining 5 will be arranged in 5 factorial ways. And these 3 internally can be arranged in 3 factorial ways. Correct? 3 packet I made for A, E and U, and then these remaining 5 letters can be arranged in 5 factorial ways, and these 3 internally can also be arranged in 3 factorial ways. No, wait, one mistake we are doing. This we are treating as a letter. So 5 remaining letters plus this letters. So there will be 6 factorial ways. That's a mistake, right? This is a packet. We are treating it as one letter. 1, 2, 3, 4, 5 and 6. 6 factorial multiplied with internal arrangement of these. That means 3 factorial. So from 8 factorial I have to subtract 6 factorial multiplied with 3 factorial. So I think 6 factorial I can take common. 8 into 7, 56 will remain minus 3 into 2, 3 into 2, that means 6, 56 minus 6, so 50 multiplied with 6 factorial. 6 factorial is how much? 120 into 6, 72, 720 multiplied with 50. 36,000, 3600 or 36,000, 3600. Let's check if we have the option. 36,000 is the option, no? So 36,000 it will be. 36,000, correct. Understood? What we did, we made a packet of all the vowels, kept them together. We treated this as a packet. This packet can go anywhere. Now totally how many letters we have? 5 remaining letters and this one packet letter. So 6 factorial will be the ways of arranging these 6 elements, and then 3 factorial for internal arrangement. These can also be arranged internally, no? So 3 factorial. So from total ways, if I subtract the ways in which all the vowels are together, remaining will be the ways in which all the vowels are not together. Okay ji? Number of selections out of n objects is 2 to the power n. But suppose if I have n objects, suppose if I have n pens, P1, P2, P3, P4, P5, P6 till Pn. For P1, how many choices are there? Selected, not selected. P2 also selected, not selected. P3 also selected, not selected. P4 also selected, not selected. So total number of ways in which I can select or not select. Total selections. For P1, how many choices? 2 choices. For P2 also 2 choices. For P3 also 3 choices. So that means one action which has 2 outcomes, I'm repeating that action n times. So 2 to the power n will be the number of ways of selecting the objects or making selections out of n distinct objects will be equal to 2 to the power n. It's just same which we learned in fundamental principle of counting in the starting. It's just very same. Exactly same, right? Either we'll select or not select, select or not select. So for every option, for every action, we have 2 choices and we are repeating the same action, selecting not from out of n things. So that means 2 to the power n will be the total number of selections. Just keep this in mind. Or we can think like this also. NC0 means selecting 0. NC1 means from n we are selecting 1. From n we are selecting 2. From n we are selecting 3. Or from n we are selecting all n. These can be the possible selections. No, from n things either we'll select nothing, or we'll select 1, or we'll select 2, or we'll select 3, or we'll select 4, or we'll select all the n. So sum of all these NC0 plus NC1 plus NC2 plus NC3 till NCn will be equal to 2n. This is sum of binomial coefficients, we know. Right? This way also we can understand like this, or we can say every element can be dealt in 2 ways, either it will be selected or not. So this way also we are getting 2 to the power n as the number of selections. Let's see the questions. There are 5 distinct apples and 6 distinct oranges. In how many ways fruits can be selected? 5 distinct apples. So 2 to the power 5 for selecting apples and 2 to the power 6 for selecting oranges. So 2 to the power 11 will be my total number of ways. That's it. Okay, 2048 will be your answer. Now, at least one fruit can be selected. At least one fruit can be selected. So, total ways minus no fruit selected. That's it. In how many ways can you select no fruit? Only one way. You didn't select anything. So, total ways were 2048 minus 1. That means 2047 should be your answer in this case. Right? Selection can be made such that at least one orange is selected. At least one orange is selected. So no orange is selected, or in how many ways can we select the oranges? 2 to the power 6 ways. In how many ways can we select no orange? Only one way. At least one orange is selected. No, in how many ways can we select oranges? Total ways to select oranges. 2 to the power 6, because 6 distinct oranges are there. In how many ways can we select no orange? 1. So total minus number of ways in which we are selecting no orange will give us the number of ways in which we are selecting at least one orange. So this will be the number of ways in which we are selecting at least one orange, and number of ways to select an apple. Selection can be made at least one orange is selected. Right? That's it. So the answer will become your 2016. Try to do these questions. Find the number of subsets. Subsets means choosing, right? Subset will be either will select 1 or not select 1. Will select 2, not select 2. Will select 3, not select 3. Will select 4, not select 4. So how many? Total 4 are there, and 2 options for each of them. So 2 to the power 4. And that's why we say that the number of subsets of a given set will be 2 to the power number of elements in the set. Right? So 2 to the power 4 will be the. So what are we doing? Either we are selecting number of ways to select from 4 objects will be 2 to the power 4. Either we'll have nothing, or we'll have just 2, or we'll have 1 and 2 both, or we'll have 1 and 3 both, we'll have 1, 2, 3 both. So total will be 16 ways in which we can do this selection or make the subsets. In how many ordered pairs PQ can be made where P and Q are subsets of A and P intersection Q is not phi? That means P intersection Q is not a null set. Come on. Why this again, piano? Come on, tell me the answer for this one. Try to think of this. So here simple way to think is P intersection Q should be a null set. That means there should not be anything common in P and Q both. So suppose if there is an element which is there in P, it should not be there in Q. If it is not in P, then it can be there in Q, or it is not in P and Q both. Right? For every element, suppose 1. Suppose we talk about 1. 1 either can be in P, or can be in Q, or can be in P and Q both. But we want P and Q, right? We want 2 sets such that element should not be there in either P or Q. I mean to say like this. Wait. Suppose there is P and there is Q. So for 1, either 1 will be, if 1 is here, then 1 cannot be over here. Then 1 cannot be over here. Or 1 can be here, then 1 cannot be over here. Or 1 cannot be both of them. Or 1 cannot be in both of them. Then only P intersection Q will become a null set. No. If an element is there in P and it is not in Q, then P intersection Q will be a null set. If an element is there in P, if element is not in P but it is there in Q, then also P intersection Q will be a null set. Third case is when the element is neither in P nor in Q, then also P intersection Q will be a null set. So for every element, we have 3 choices: in P, not in Q, not in P, in Q, not in P, not in Q also. 3 choices we have. For every element, these 3 choices are there. Either it should be there in P, not in Q, right? Or it should be not in P but in Q, or it should be not in P and not in Q. Right? It should not be. So every element has 3 choices, and this thing is being repeated 4 times. Right? 4 elements are there. So what should be our answer? 3 choices. So 3 to the power 4 will be our total number of selections. 3 to the power 4 will be our total number of selections. Every element, either it will be in P or not in Q, not in P then in Q, not in P, not in Q. 3 choices for every element. 3 choices are there for every element. Then only A intersection P will be a null set. So 3 to the power 4 will become our answer. How many ordered pairs such that can be made? P and Q are there, contains exactly 1 element. Now think, P intersection Q contains exactly 1 element. So one common element, the common element which is there contains exactly 1 element. That common element, in how many ways can you choose? Right? P intersection Q contains exactly 1 element. Remaining 3 should not be P intersection Q. That means 1 element should be common in all 3 of them. That one common element, choosing common element, how many ways? How many ways, in which how many ways we can choose the common element? Choosing common element, out of 4, any one can be common. So 4 ways to choose the common element. Correct. Remaining should result in 5. That means 3 to the power. That means 3. That means remaining 3 will have 3 choices. In P, not in Q, not in P, in Q, not in P, not in Q. Right? So 3 to the power 3. Right? First we'll choose the common element. Then we'll arrange the remaining 3. Then we'll select the remaining 3. So both the things we are doing simultaneously. That's why this will be your answer. 27 into 4. 108 I think. Right? 108. Now selection of like objects. In how many ways over here, if you observe, in how many ways can you choose A out of these 4 A's? Only one way. In only one way you can choose an A out of 4 given A's. Good evening sir, sorry for late. No problem Sagar, how are you? Okay, number of ways of selecting 3 letters out of this. This is okay. In one way only we can choose an A. But if you look at second one, here you'll have to make cases. Why? Number of ways of selecting 3 letters out of these. We have 3 A's, 2 B's and 3 C's, and we have to select 3 letters. Right? What can be the cases? What can be the cases? All 3 different. All 3 different. All 3 are different. If all 3 are different, to do that, how many ways? One way only. 1 A, 1 B, 1 C. Right? We'll choose 1 A. To select 1 A, only 1 way is there. To select B, only 1 way is there. To select C, out of 3, we'll have 1 way is there, because all 3 are same. So all 3 are different. A, B, C, C, B, A. Arrangement, it is not asking about arrangement. Don't think, sir, but A, B, C, C, B, A and D, A, C are different. It is only asking only about selection. In how many ways can you select 3 different letters from this? 3 different letters. Either we'll select all the 3 different, or what we can do, we can select all 3 same. All 3 same, we can do this also. All 3 same. All 3 same, how many ways will be there? Either all the 3 will be A, or all the 3 will be B, or all the 3 will be C. But B are only 2. So if we want all the 3 to be same, either they can be A or can be C. So only 2 ways are there. Correct? Now, 2 same, 1 different. This can be the third case. Either all the 3 different, all the 3 same, or 2 are same, 1 is different. Right? 2 same I'm choosing and 1 different I'm choosing. Come on. Two same. To select 2 same. In how many ways I can select 2 same? 2 same I can select either 2 A's, 2 B's, or 2 C's. Right? So 3 ways. In 3 ways I can select 2 same letters. Either they'll be A or B or C. 1 different. Remaining 1 different. Because I've selected from, 1 should be different. Right? One of the letters I've selected. 3 ways to select 2 letters. 3 ways to select 2 same letters. And now 1 should be different. Remaining 2 choices, that means into 2. So total will become 6 plus 3, that means 9 ways. In total 9 ways, I can choose 3 letters out of 3 A's, 2 B's and 3 C's. Please analyze this carefully. I'll take just a small break. Okay, I'll just take a small break and we'll be back. Star Girl, please be back. You can take a small break too. Okay, now let's do some questions based on this. All right. In how many ways can we select 4 letters out of the word examination? We have, it's written, E is occurring 1 time, X is occurring 1 time, A is occurring 2 times, M is occurring 1 time, I is occurring 2 times, N is occurring 2 times, T is occurring 1 time, and O is occurring 1 time. Okay, in how many ways can we select 4 letters out of the word examination? Now 4 letters, what can be the cases? All 4 different. Obviously this can be the case. All 4 are different. This can be the case. Correct, all 4 can be different. So out of 8 letters, 1, 2, 3, 4, 5, 6, 7, 8. Out of 8, you have to choose any 4. So this will be just 8C4. Right, 8C4. If out of 8, we can choose any 4. Right? 8C4. What else? Selection. Here it is selection. Now, two same of one kind, right? We can do like this, no? These two same, right? Two same and two same. Two same, I mean two same of one kind and two same of another kind, right? Two same of one, or we can say two alike and two alike. Like that also you can do, no? Because three cannot be same. Three cannot be same. Why? Because three letters are not, there is no letter which is repeated three times. So we don't have three A's or three B's or three E's, right? Two same and two same we can do, correct? Or what else can be the case? Three different, or sorry, two are same and two are different. These two are same and two different, right? This can also be the case, right? For example, here two A's and here we are having two A's and here we are having two I's. This can be the case. All four can be different. These two can be same, these two can be same. These two same of one kind, these two same of another kind. These two same and these two are different. This can be the case. Apart from this, all four will be different, right? If I cannot include anything else, no. If I include two different means all four different. Either all the four will be different or two of one kind will be same, these two will be of another kind. These two can be same and these two can be different, right? Now for two same and two same. So two same, which two are where we have same letters? A is occurring two times, I is occurring two times, N is occurring two times. Correct. So from three, I have to choose any two. From three of these, I have to choose any two which are going to be selected, right? Three pairs. This is one which is occurring two times. This is one which is occurring two times. So I can have two A's, two I's or two N's. So from three sets, I can choose any two set to make two same and two same. Correct? From the three sets of same letters, I can choose any two sets. I can select any two sets. Either I can select this set or this set or this set or this set, any two sets. So this way I'll have two same and two same. Two same of one kind and two same of another kind. Now, for two same again, from these three, I have to choose any one. These two are same. For example, from these two are same. This and this is different. This and this is different. So for these two to be same, from these three pair, I can choose any one pair. From these three sets, I can choose any one set, right, to fill this one, right? Any one set will fill this one. This is different, this is different. From remaining ones, that means from the remaining letters which are occurring one time, 1, 2, 3, 4, 5 or more. Come on, now what should I multiply it with? Two same and then two are distinct. Now there are two I's. So total sets, how many I have? 1, 2, 3, 4, 5, 6, 7 and 8. One I have chosen from these three. So remaining will be 7. From the 7 remaining sets, A, E, X, suppose I chose A to fill these two, right? So A will be excluded, but I and N will be included. No, from these 7, that means E, X, M, I, N, T and O, I can choose any one. So it will be 7, C, 2. Now from 7 I have to select any two and they cannot repeat. They will be different because I am selecting 2. Okay, so that will be the third way. So just sum all of them up. 8C4 plus 3C2, total will be 8C4 plus 3C2 plus 3C1 into 7C2. Very attentively you have to solve these type of questions. Are we clear? Okay, yeah, all right. Next, try to do this question which came in 2024. Come on, tell me the answer for this one. Right, first let's write how many m's are there. M's are 2, A's are also 2, A's are also 2, right? And what else is repeating? T is repeating. T is also 2 times. Anything else which is repeating? E? No, I don't think E is repeating. So H, I, C, S and E. Okay, only M is repeating. Where the chosen alphabets are not necessarily distinct is equal to number of ways 5 alphabets can be chosen. Chosen means selected from these alphabets. Now 5 are to be chosen, 5 to be selected, 5 are to be selected. Now write the cases. What all cases are possible? Okay, 2 only. Maximum a letter is repeating is 2 times. All 5 are distinct. One case will be all 5 distinct. All 5 can be distinct because we have 1 2 3 4 5 6 7 8 letters we have, 8 options we have. All 5 distinct can be there. All 5 distinct. To do this, what we'll have to do? 1 2 3 4 5 6 7 8. From 8 any 5 we have to choose, right? For selecting all 5 distinct, 8C5 will be the number of ways to choose any 5 from these 8, right? All 5 letters will be distinct in this case. From these 8 boxes, you are selecting 5, right? Where this box contains 2 M's, this box contains 2 A's. What else can be the scenario? 2 same, maximum 2 can be same, right? Maximum 2 can be same, not more than that. Right, maximum 2 can be same. So 2 same, we can say 2 are same and remaining 3 are different. Right, remaining 3 are different. So for selecting 2 same, from these 3 boxes has 2 same things. So from these 3 you'll have to select any one so that 2 remain same. Right, now from the remaining 3 different, so from the remaining any 3, 1 2 3 4 5, from the remaining 5 any 3. No, not from the remaining 5. From these 3 you have chosen 1, so remaining will be 7 will be remaining now, right? From these 3 you have chosen just 1, so out of remaining 7, you have to choose any 3. From remaining 7, for 3 different you have to, from remaining 7 you have to choose any 3, correct? What can there be any other case? We can have one case, 5 letters, no, so 2 same of one kind, another 2 same which are of another kind, and last one is different. Remaining one is different. So 2 same of one kind. That means from these 3 you have to choose any 2, right? From 2 same of one kind would mean what? These 2 should be same, these two should be same, these 2 should be same, right? So 3C1 into 3C1 actually 3C2, or you can do 3C2 directly. You will not do like this, no. You'll choose first you'll choose from these 3, then again you'll choose from these 3. You'll simultaneously, it's better to choose any 2 out of these 3 so that they'll make 2 same and 2 same over here. So if you choose any 2 out of these 3, that will give you 3C2. Any 2 out of these 3, 3C2. Okay, any 2 out of these 3, here same, any 2 you have chosen. MMAA, it can be AATT, it can be AAMM, it can be TTMM, it can be MMTT, anything, right? So out of these 3 packets you have chosen any 2 packets so that these 2 are of same one kind and these 2 are of same another kind. Remaining 2 you have chosen, so out of 8, remaining 6, 2 you have taken. From remaining 6 you can choose any one multiplied with 6C1. Let's calculate this answer to verify. 8C5, that means 8 factorial, 876 divided by 5 factorial, okay, into 3 factorial. So 3 into 2. So 2 here, 2 4s here. Okay, this is 28 into 2, 56. Alright, so this will become 56 plus 7C3 into 3. 7C3 will become 7 into 6 into 5 into 4. upon 4 factorial into 5 only, upon 3 factorial will be gone. So this will become, this will get cancelled, this will get cancelled 2 times, this will get cancelled. So this is 35, 56 plus 35 plus this is 3C2, so 3 only, right? 3C2 or 3C1 is same, so 3 only, and 3 into 6, 6 3s are 18. What is the total? 12, 8, 9, 10. Answer is not coming correct, yeah? 8C5, acha 8C5 is correct, 56. Then 3C1 into 7C3, 7C3, into 3 we didn't do. 36 into 3, 35, 7 5s are 35 into 3 we'll have to do, no? This will be 7 5s are 35, 35 into 3 will be 105. 105 plus 18. Now the total is coming 179. Yes, this is equal to 179, which will be your answer. Alright, easy question. You just have to remember that while doing these type of selection questions, you will have to make cases. Right? Don't forget to make cases in this case, in these type of questions. One is this type of question. Wait, I'll show you. Yeah. Number of triangles whose vertices are at the vertices of rectangular octagon, but none of whose sides is a side of octagon. Come on. The total number of triangles whose vertices, suppose if I have 8 points which are all non-collinear, right? 8 points which are all non-collinear. So number of triangles from 8 non-collinear points independently, non-collinear, none of them are collinear with each other. No 3 points are collinear. So that is 8C3. Okay, 8C3. Now suppose if I have 4 points like this and I have 3 points like this. Now how many triangles I can make using these points? So total points are 4, 11. Total 11 points are there. So 11C3, but minus the collinear points. That means minus this. That means from 5C3 I will subtract from the side, because these are collinear, and minus this also. That means 5C3 from here also and 4C3 from here also. Right? Because these will make collinear points. So total 11C3. Right, from 11 any 3 to choose any 3 points, this is the number of way, minus 5C3 because of these collinear points, minus 5C3 these collinear points, minus 4C3 these collinear points. Right, this is how we make the triangles connecting points in a plane. Now think about this question. Now total number of vertices in octagon, total number of triangles will be how much? Total triangles will be how much? 8 vertices are there in an octagon. 8 vertices, that means 8 points. From these 8 points, any 3 I'll have to select. So total 8C3 will be the number of 8C3 will be the number of ways to select any 3 points from the 8. Now, what is it saying? Of a regular, but none of whose sides is a side of octagon. Now, number of triangles which will be formed with 2 sides common with octagon. Right, octagon is like this, no? 1, 2, 3, 4, 5, 6. Wait. 1. Right, this is how an octagon is. Right. There can be a triangle whose 2 sides are common, whose 2 sides are common with the octagon. Number of triangle can be there whose 1 side is common with octagon. There is a possibility, right? How many triangles? Suppose we are joining these 3 points. Suppose I am joining number of whose vertices are vertices of regular octagon. So suppose I am joining this one and this one. This is a valid triangle. Its sides are not coinciding with the sides of octagon. But suppose if I choose this particular triangle, then its one side is coinciding with the side of octagon. I don't want this type of triangle. Now think, how can we solve this? Or there can be a triangle like this also, right? This is also by joining the vertices, but its two sides are common. Correct? Its two sides are common with the octagon. This triangles, this side and this side, both are common with the octagon. So this also not selected. Only the octagons, only the triangles whose side, this triangle is also not allowed. Why? Because the side of this triangle is coinciding with side of the octagon. So only those triangles I want whose side is not, whose side is regular, but none of whose side is not coinciding with the side of octagon. Those type of triangles only I want. So now think how. For example, if I make this triangle, its sides are not coinciding with the sides of octagon, this triangle will be allowed. So now simple way to think, total number of triangles will be 8C3, which will be formed. Number of triangles whose one side will be coinciding with the octagon, there will be such 8 triangles whose one side, because this type of triangle, right, number, how many triangles will be there such that only one side will be coinciding with the side of triangle. Obviously 8 sides are there in octagon, so there will be 8 such triangles whose one side will be coinciding with the side of octagon. That means -8 I'll have to do. One side is coinciding with the octagon. Now the number of triangles whose two sides are coinciding with the side of triangle, how many will be like that? Come on. Think about it. Two sides. Bhai, this will be, if two sides are coinciding, that means 8 multiplied with 4, all these 8, one more side, that means half of 8, that means 4, and also the two sides which will be with 8. This should be the expression. Now tell me. Just give me a minute please, I'll check this sound. Where is it coming from again? Sorry, yes. So I was saying, yeah, this question. Let me start from here again. Total number of ways in which total number of triangles using 8 points will be 8C3. That we understand, right? Total number of triangles that we can make from 8 points. That means 8C3 will have to select any 3 points from out of these 8 points so that we can make triangles. But none of whose side is a side of octagon. So all the 3 sides of triangle cannot coincide with the sides of octagon, because 3 sides of triangle cannot coincide with the 3 sides of octagon. Either one side coincide or 2 sides will coincide with the sides of octagon. Correct? Either one side will coincide or 2 sides will coincide with the side of octagon. Now, when will one side coincide? One side coincide means either this, either this, either this, right? Either this, either this. Let's discuss first. When any 2 sides are coinciding. Any 2 sides are coinciding means these type of triangles. These type of triangles, correct? Correct. These type of triangles are having 2 sides coinciding with the octagon. So how many such will be made? Just think about it. Just think about it. Simply count it. Don't get into NCR and all that. Right? Any one point can be connected with any other. If I connect this point with this, then also 2 sides of the triangle are coinciding with what? With the side of octagon. Right? If I connect these two, then also 2 sides of triangle are coinciding with these two again, right? These two again, these two. So every point is going to have that. So total number of 8 such triangles will be formed, because 8 points are there. From every point connecting with alternate point, I can make a triangle which is coinciding. 32 in the one side. Yes, very good. 32. That means 8 multiplied with 4 will have one side coinciding. One side coinciding means only one side coinciding. That means 2 sides from this and one is different. Two adjacent vertices are joined and one is different. So there'll be total 8 multiplied with 4. That means 32 such triangles will be there. So our answer will be nothing but 8C3 minus 32 minus 8. What should be? It will be 16. Answer will be 16. Very good, Sudesh. Great, great. So one side coinciding will be with 32 triangles will be there, where one side will be coinciding. Total 8 multiplied with 8 by 2. Right? These 8, just third point means 8 vertices can be used connected with 8 divided by 2. That means 4 vertices. So 8 multiplied with 4, that means 32. That's how we are getting. Okay. Find the number of triangles that can be made joining marked points. Simple, right? So total points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means 10 C3 will be the total number of triangles subtracted collinear. 1, 2, 3, 4, 5, 6 subtracted from 6C3, and these 1, 2, 3, 4, 5 minus 5C3. That will be your answer. 10C3 minus 6C3 minus 5C3. These type of questions are frequently asked, right? This was asked in 2024. There are 5 points P1, P2, P3, P4, P5 on side AB excluding A and B of triangle. Then 6 points like this, 7 points like this. Then the number of triangles that can be formed using the points P1 to P18. Simple question it was. Look, this is on AB. There are 5 points. On AC there are 12 to 18. That means 7 points, and on BC there are 6 points. So total will be 18C3 minus these, that means 5C3 minus these, that means 1, 2, 3, 4, 5, 6 minus 7C3 minus these, that means 6C3. This will be your answer. 18C3 minus 5C3 minus 7C3 minus 6C3. This will be your answer. That's it. In triangle problem, simple solution is there. Remember how to do these. And this is also frequently asked. How many batting orders of 11 players can be made out of 15 players such that 2 particular players are always among the selected 11s? Selection only. We did these type of problems, right? So 2 particular players are always there in the 11. That means you have to select just 9 people. Out of how many people? 2 are already selected. So 15, 13. See, out of 13 people, you will be selecting just 9 people. Why? Because 2 people are already selected. So you are doing your selection from 13 remaining people only. And how many you have to select? 9 only, because 2 are already selected. So 13C9 will be your answer. Okay. This is how many batting orders it is asking. How many batting orders are possible? So selection, once you select it, then arrange these 11 people. From 13, you are selecting 9, and now 11 people will be arranged. Total are 11 people, now 2 are already selected. The selections you can make, the teams you can make, the different teams that you can make will be 13C9, and in that batting order you have to select. So 11 factorial. You have to arrange also in this case. Okay, gap method and block method. I'll show you with questions. So here we have already been doing gap method and block method. Just trying to show you some couple of questions so that you can understand it clearly. In how many ways 7 boys and 4 girls can be arranged in a row such that no 2 girls are together? So total number of ways minus the number of ways in which 2 girls are together. Right? That's what. We have done these type of questions. Can you tell me the answer for this one? In how many ways 7 boys and 4 girls can be arranged? Not selection, arrangement. Arrangement we are doing. Arrangement. 7 boys and 4 girls can be arranged in a row such that no 2 girls are together. No 2 girls are together. That means B1, B2, B3, B4, B5, B6 and B7. Now gap method means if I want no 2 girls to be together, in that case what will I have to do? I'll have to make the girls sit in these gaps. Right? I'll have to make the girls sit in these places. Then only no 2 girls will be together. No? Correct? Or total minus, how will I do? Total minus when 2 girls are together. But 2 specific girls should be together. In that case, I'll do total minus 2 girls which are together when I know which 2 girls are together. Here it is saying none of the 2 girls should not sit adjacent to each other. They'll talk too much or they'll fight, whatever is the reason. But yeah, so we do these type of questions with the gap method. Simple thing. Number of ways to arrange 7 boys will be 7 factorial. These 7 boys can be arranged in 7 factorial ways. Remaining 4 girls are there. And for 4 girls, how many gaps are there? 1, 2, 3, 4, 5, 6, 7 and 8. 8 gaps are there. And from these 8 gaps, I have to choose any 4 gaps. Right? Obviously 4 girls I have to arrange. So from these 8 gaps, I have to choose any 4 gaps, and then I'll arrange 4 girls in these 4 gaps, which will be done by 4 factorial ways. So the complete answer will be 7 factorial into 4 factorial multiplied with 8C4. Okay. All girls are together. All the girls are together. All right. So 1, 2, 3, 4, 5, 6, 7. 7 boys are together and remaining 4 girls are together. So 4 girls, what will I do? This is called block method or box method. I'll put these 4 girls in a box. So this is box G, box of girls. All 4 are sitting together. Right? Now total number of things to arrange will be 7 boys plus 1 box of girls. That means 8 things I have to arrange. right? 8 things I have to arrange. These girls can be in any of these places, right? Any of these places. Multiplied with 4 factorial, because girls can be internally arranged. So 4 factorial will be multiplied. All right. Okay. All girls are together and all boys are together. So one block of boys, one block of girls, right? One block of boys, 1, 2, 3, 4, 5, 6, 7. One block of girls, 1, 2, 3, 4. These boys and girls can be arranged in 2 factorial ways. 2 ways. Girls first, boys after that. Boys first, girls after that. 2 ways, right? Boys internally can be arranged in 7 factorial ways. Girls internally can be arranged in 4 factorial ways. That's it. Right? 2 blocks I created. This is block of boys, this is block of girls. All boys are also together, all girls are also together in this case. Okay. No, not all the girls are together. Total minus, not total minus when all girls are together. Total minus when all girls are together. What is the total number of ways? 11 factorial, in which we can arrange all of the 11 people. Total number of ways to arrange 11 people is 11 factorial, in which all the girls are together. We found it here. All girls are together. This one. All girls are together. So 7 factorial multiplied with, sorry, 8 factorial. 7 these and 1 box of girls. 8 factorial multiplied with 4 factorial for internal arrangement of girls. So 11 factorial minus 8 into 4 factorial. All right. This question. Let's see this. Hey, we solved this. This came again. Okay, anyway, we solved this already, right? Group A consists of 7 boys, 3 girls, while Group B consists of 6 boys and 5 girls. Number of ways 4 boys and 4 girls can be invited for a picnic if 5 of them must be from Group A and remaining 3 of them from Group B. This came 2025 only, this year question only. Come on, tell me. Right, 7 boys are there. 7 boys. And how many girls we have? 3 girls we have. This is, okay, let me write like this. Group A consists of 7 boys and 3 girls, right? And your Group B consists of 6 boys and 5 girls. The number of ways in which 4 boys and 4 girls can be invited for a picnic if 5 of them must be from Group A and remaining 3 must be from Group B. So obviously here we'll have to make cases, right? Case number 1. What will be case number 1? We want 5 of them from Group A and we need 4 boys and 4 girls. So suppose we are choosing 4 boys from Group A and 1 girl from Group B. Total boys and girls should be 8. 4 boys from Group A. Now 5 of them should be from Group A. So we made 5 of them from Group A, right? And from Group B, from Group, sorry, 4 boys, all the 4 boys and A remaining from the, and remaining 3 from Group B. Remaining 3 from Group B. So 5 we have already chosen. But now can we do anything? We cannot have 4 boys actually, right? If we choose 4 boys from Group A, remaining 3 people which we are supposed to choose, total 8 people we have to still choose 3 girls, right? We have to still choose 3 girls, right? But from Group B there should be 3 people chosen. There should be 3 people chosen, correct? So we'll have to choose 3 girls and 0 boys. So if we are 0 boys can be chosen and 3 girls can be chosen. This is a valid case, right? 4 boys, 1 girl from Group A, total 5 people from Group A, total 3 people from Group B, and yes, 4 boys and 4 girls are there. So this can be a case. Any other case? Case number 2. What can be the case? Suppose we are choosing 3 boys and 2 girls. That's how we can choose 5 people from Group A. So from Group B, 4 boys we have to choose. So 1 boy will be chosen. And how many girls will be chosen? 5 we have already taken. So 2 girls will be chosen. Right? That's how 4 boys and 4 girls we are having. Case number 3. Right? 2 boys, 2 girls. So from here also 2 boys and 2 girls will have to choose. Can we choose one boy and one girl? Can there be a case where we are choosing one boy and one girl? No. We have to choose 5 people. Can we choose one boy and 4 girls? But group A has 3 girls only. So from group A, how will we choose one boy and 4 girls? Right? We have to make 5 in group A, na? So how can we choose 4 girls? Because group A consists of 3 girls only. We cannot do this. Sir, okay, no problem. Can we choose like this from group B? One boy and 4 and from in group B, how many we need? 3 and 2 girls. This we have already made the case. So there are no other cases possible. So making the case is the main thing. Now you can solve this question. Case 1 plus case 2 plus case 3. Right? So case 1 will give you how much? 4 boys out of 7 boys and 3C1. 7C4 multiplied with 3C1. Correct? And from group B also same thing, in multiplication 6C2 and 0 boys we have to select, so not selecting anything, and 5C3 multiplied with 5C3 plus 7C3 3C2 multiplied with how many boys in group B? 6C1 multiplied with 5C2 plus 7C2 multiplied with 3C2 multiplied with 6C2 multiplied with 5C2. That's it. From 5 we have to choose 2. So this will be your total number of ways. You have to add that, and I think it should come to 8575 or 8925. I remember this. I think this should be your answer. I should have this. 8925 is the correct answer. 8925 is your correct answer when you add all these cases. Sir, 2 boys and 2 girls from group A. There are no 5. There are no 5. Very good. Now this thing, number of ways of arranging when some objects are like. For example, here in mummy word, suppose you want to arrange these letters. Now 3 letters are same, right? M's are same. You write M like this or M like this. How will you know which M is? The M's are all same, no, not a difference. There is no difference. So how do you do this? P factorial. Now number of ways of arranging P elements in a row if out of P objects M are alike and N are alike. Here 3 are alike. Correct? 3 are alike. So total are 5 factorial divided by how many are alike? 3 are alike. So 3 factorial. Here total number 1, 2, 3, 4, 5, 6, 7 factorial divided by how many are alike? 2 are alike. A are alike. One type. 2 A's are there and 2 R's are also there. So 2 factorial for R's. There is nothing else which is repeating. This will be the number of ways in which we can arrange. A, B, B, B. Total are 5 factorial. 2 of same type, 2 factorial, and B. 3 B's are there. So 3 factorial for B. In this case, total 7 factorial divided by 2 factorial into 3 factorial into 2 factorial. That's it. Right? So in division, write the like objects. 2 A's are there, so 2 factorial. 2 R's are there, so 2 factorial for that. 3 B's are there, so 3 factorial will be divided. 2 A's are there, so 2 factorial it will be divided with. This you should know. On basis of this only, this question came. Number of words with or without meaning that can be arranged using the letters of the word assassination. How many A's are there? A's are 3. How many S are there? 1, 2, 3, 4. 4. Okay. Then I is occurring 2 times. Then N is also occurring 2 times. And I done, A done, T is occurring 1 time only. O is occurring 1 time only. How many is total? 4 plus 4, 8, 9, 10, 11, 12, 13. And here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 13. Yeah, total 13. So 13 factorial. Okay. So that the vowels occur together. That is also one condition. Vowels should occur together. right? How many are vowels? So vowels are A, I and O. A is occurring 3 times, I is occurring 2 times, O is occurring 1 time. Okay, all the vowels are together. So what we'll do, we'll make a packet of vowels, right? Except these 3. How many are there total? Except these 3 total, how many are there? 1, 2, 3, 4, 5, 6. Right? Except these 3, all the vowels should be together. No? Number of ways in which we can keep the vowels together. So we'll keep vowels together. A, I and O will be the vowels. Remaining S, N, T will not be the vowels. S, N and T are not the vowels. So for arranging S, N and T, right? How many S are there? 4. 2 N's are there. 6. T is 1. Huh? T should be assassination. Any word which we are missing? Kya? Okay, no problem. Right. Now, if we simply ask about total number of arrangements will be 13 factorial upon 3 factorial into 4 factorial into 2 factorial into 2 factorial. This will be total number of arrangements. But here they are asking you have to keep the vowels together. So S, I and S, T and N we have to keep in one packet, not one packet. S, T and together simply A, I and O in one packet. This is one packet. So total number of letters which we have now are S is 4 times, T is 1 time, N is 2 times. Right? So 4, 5, 6, 7 and this packet 8. So total 8 things we have to arrange where these are, this is occurring 4 times. So 4 factorial. T is not repeating, N is repeating 2 times. So 2 factorial. Now multiplied with internal arrangement of vowels. Vowels over here. How many are there? 3, 4, 5, 6. Right? So 6 factorial divided by 3 times A is repeating, so 3 factorial and 2 times I is repeating, so 2 factorial. This will be your answer. This is how you are going to get your answer. Okay. Simple question, I think. Not a difficult one, but do try these questions on your own. Right? Solve these questions on your own so that when they come in exam, you can simply answer them. Okay. This question again, total number of words that can be formed out of letters of the word distribution taken 4 at a time is equal to. You have to just take 4 letters at a time. Now, you have to make cases in this. Right? We have to make cases in this. So we have, I think, we'll make the cases. I is occurring 3 times. Right? I is occurring 3 times. Then T is occurring 2 times. I is there, T is there. D, rest, I think rest is, rest nothing is repeating. O is not repeating. I, okay, I we have written 3 times. T is repeated, so R is not repeating, B is not repeating, N is not repeating. So remaining D, S, R, B, U, O and N. These are not repeating. Right? Taken 4 at a time. Right? So number, now we'll have to make cases. Right? 4 we are choosing. So case 1. Right? Case 1 is 3 are same. Right? 3 are same. 3 same. 1 different. Because maximum 3 can be same. Right? Maximum 3 can be same. All 4 cannot be same. 3 same, 1 different. This is one case. Case number 2. Case number 2. Right? Two same of one kind and another also 2 same of another kind. Right? This can be the case. Correct? Now what else can be the case? Case number 3 can be 2 are same and remaining 2 are different. This can be the case. Case number 4, all 4 different. All 4 different. Right? In this case, we'll have to make cases. All 4 different. 3 same, 1 different. That means 3 same and 1 different. 1 different we can choose 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are total 9. Total 9 are there. Now, when 3 are same and 1 is different, so which one is different, that only we have to choose. 3 are same only in one case. There is only one way in which we can keep 3 same. So only I can come. Which one is different? To choose that, we'll choose out of remaining 8, we'll choose any one. 3 same, all 3 I's are there. Only one case is there where 3 same can be there. One different. Right? Now, we have to make words, the total number of words which can be made in this case. Arrangement also we have to do. Arrangement, how will we do? In 4 letters, that means 4 factorial, 3 are of same kind. So 4 factorial divided by 3 factorial. Understood? 2 same, 2 different. Now 2 same, which either these 2 can be same, 2 same of one kind and 2 same of another kind. Right? 2 same of one kind and 2 same of another kind. That means from these 2C1 only I'll have to do. Right? From these 2, both I'll have to choose. No, 2 same of one kind, because these only are repeating. So both I'll have to choose. I'll have to choose 2 from this and 2 from this. There is only one way, because 2 letters only are repeating. Right? So there is only one way. Now it's just about arrangement. Right? 4 I'll have to arrange, and 4 I'll have to arrange, and from these 2 are repeating. So 2 factorial, because these 2 are repeating, these 2 are repeating. Correct. Case 3, 2 are same and 2 are different. Which 2 are same? Now I'll have to select. Out of these 2, which 2 are same? So 2C1. Right? First I'll select. Okay. Then 1 I have selected. From the remaining 2. From the remaining 8, I'll have to select 2 which are different. From these 2 I have selected 1 which is going to give me same. These 2 will come same. These 2 should be different. So from remaining 8, I'll have to select 2. Now I'll have to arrange where 2 are same and 2 are different. So 4 factorial divided by 2 same, that means 2 factorial. And all 4 are different. All 4 are different. That means from these 9, I have to choose any 4. That means 9C4. And in how many ways I can arrange these 4? 4 factorial. So my answer will be 8C1 into 4 factorial by 3 factorial. It will be 4 only. 8 into 4, 32 anyway. Plus 4 factorial divided by 2 factorial into 2 factorial. Plus 2C1 into 8C2 into 4 factorial divided by 2 factorial. Plus 9C4 multiplied with 4 factorial. This is how we do questions of selection. Okay, this will be your answer. The total will come out as 3734. Just check your answer once. 3734 will be your answer. On this basis only, this question came. Now try this one. This question came in 2025, this year only. If P is a set of 7-digit numbers with sum of their digits equal to 11, if the number number in P are formed using the digits 1, 2 and 3 only, then the number of elements in the set P, again make cases, the total number of digits in a 7-digit number should be equal to 11. Now if I include 4 threes, can my sum be equal to 11? No. Obviously, if I include 4 threes, already sum is becoming 12. If I include 3 threes, suppose these 3 are threes. Now, even if I have to fill all the places. So even if I put 3 ones, no, then my sum is becoming 11. I don't have space for any other one. So maximum threes which I can include is 2 threes. Right? I can include 2 threes. Right? When I'm including 2 threes, remaining should be 1. 6, 7, 8, 9, 10 and 11. This way 1, 2, 3, 4, 5, 6, 7. 7-digit number is being formed. This is your case number 1. This is case number 1. Correct? What else? You choose 1, 3, 2 2s, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. That also is giving 7 letters. So case number 2. Right? This is how you should make cases. Case number 3. I'm not including any 3 now. Right? Because minimum 1, 3. Now not including any 3. 2, 2, 2. Can I include 4 2s? 8, 9, 10, 11. Then 3 ones only will be repeated. 4 plus 3. I can include 4 2s. I can include 4 2s. 1, 2, 3, 4, 5, 6, 7. 8 plus 3, 11. This is my case number 3. Case number 4. Is case 4 possible? What else can I do? I cannot do 5 2s. Right? If I'll do 5 2s, then this here also will be 2, 10. There will be only space for 1 left. So 2 2s I've included. Not including any 2 with all ones, I cannot make 7. I cannot make 11 using all ones. So using 1 2 and remaining ones, no. 6 ones will make it 6, 7, 8. No. If I use 5 ones, no other case is being formed, right? Can you see that? If I use just 1 2 and remaining all 6 as 1, the sum will be 2, 8. If I use 2 2s, which I've included, if I use 2 2s, suppose, so 4, remaining all should be 1. 1 2 3 4 5 6 7. Yeah. If 2 2s, 1 1 1 1 1 1 2 3 4 5 1 2 3 4 5 6 7 8 9. The sum is 9 only. So case 4 will not be made. Only 3 cases are possible. You have to very carefully think about the cases. Okay. In the first case, what we'll have? 7 factorial divided by 1 2 3 5 factorial into 2 factorial. 1 is repeating 5 times. 5 factorial into 3 factorial. This is 2 to 3. So this will be 7 factorial divided by 4 factorial into 2 factorial. This will be 7 factorial divided by 3 factorial into 4 factorial. That's it. Sum of all these. Okay, sum of all these will be my answer. This was a simple question. Answer should be equal to, this will come as 7 6 are 42, 7 3 2 by 3, 6 by 2, 3 7 3 are 21, right? 21, and this will become 765 divided by 2, so 105, and this will become 765 divided by 3 and 2, 35. So total answer will be 140 plus 21, 161. 161 was your answer. I think options were there in this question, but I forgot to include maybe. 161 is the correct answer. Okay, this question again, 2025. Try to do this. Come on, try this question on your own. The number of different 5-digit numbers greater than 5,000, number should be greater than 5,000, can be formed using the digits 0, 1, 2, 3, 4, 5, 6, 7 such that the sum of their first and last digit should not be more than 8. Again, you'll have to make cases. Right? Here also, you'll have to make cases. Okay. Sum of first and digits are from 0 to 7. The digits are from 0 to 7, and you have to make a 5-digit number greater than 5,000. 1, 2, 3, 4, 5 greater than 5,000. That means here 5 can come, 6 can come, 7 can come. Correct? Here 5 can come, 6 can come. This place can have 5, 6 or 7. Right? Then only the number will be greater than 5,000. No? Right? Here 5, 6 and 7 can come. Now case 1. Now we'll make cases. Case 1 where first digit is 5. 1, 2, 3, 4 and 5. First digit is 5. What can be the other digit? The sum of first and last digit cannot be more than 8. So the last digit can be 0. The sum is, right? Second case where first is 5 and last is 1. Third case, first is 5, last is 2. Fourth case, first is 5, sum should not be more than 8. Not more than 8, no. So 5, 3 we can include. So 5 and 3 we can include. Case number 5, 6 can also come here. 6 and 0, 6 and 1, 6 and 2. So this will be 6th case, 7th case, 8th case, where 7 can come and here 0 can come. 9th case, where here 7 can come and here 1 can come, because sum should be not more than 8. 7, 1 is also possible. So total 9 cases we are getting. Correct? These 9 cases we are having. In these 9 ways, we can have first and last digit sum which is not greater than 8 and the number is also greater than 5000. Okay, number is also greater than 5000. So 9 cases, and remaining 3 places. Remaining these 3 places I can arrange using remaining any 8 letters. Right? 0 to 7, 8 letters are there. So 8 multiplied with 8 multiplied with 8. Repetition is not allowed, right? Repetition is allowed. It's not given anywhere that repetition is not allowed. So repetition is allowed. We'll assume that repetition is allowed. So this will be the total number of ways in which we can do. Anything else? Numbers greater than, how much will this be? 8 is the 64. 512 into 9. 4 6 512 into 9 18. 4608. 4608 should be your answer. 4608 is then the options. Yes, it's there in the options. Something is fishy. Number of different 5-digit numbers greater than 5000. No, wait. We'll have to subtract 1 from this. Why? Because 5000 is not included. We have included 5000 also over here. Right? If all these 3 become 0, then 5000 is included. No, so minus 1. 5000 is not included. Greater than, equal to, greater than 5000 they have given. Is not included. So answer would be 5607. Otherwise these 2 close options won't be given. That's how it clicked my mind that something is fishy, because it's written no greater than 5000. 5000 cannot be included. So making of cases, guys, is the most important thing you must be observing. You should be able to analyze your problem clearly. Now there is one thing called dearrangement problem. Right? These type of problems generally are asked in advance. Sometimes in mains also they have asked questions on based of this. I'll explain you how. What is this? It means that suppose letter 1, letter 2, letter 3, letter 4 and letter 5 are there. Letter 1 should go to house number 1, letter 2 should go to house number 2, letter 3 should go to house number 3, letter 4 should go to house number 4 and letter 5 should go to house number 5. Now dearrangement means they'll ask you in how many ways are there in which none of the letters goes to its designated address. That means letter 1 can go to H2, H3, H4, H5 but not H1. Similarly, letter 2 can go to H1, H3, H4, H5 but not H2. Letter 3 can go to H1, H2, H4 and H5 but not H3. So that is dearrangement. In how many ways can you dearrange an arrangement? For example, this kind of problem. Find the number of dearrangements for 4 letters. How many ways are there such that only one letter goes to its address? How many ways in which only one letter goes to its address? So, in how many ways? Dearrangement of 4 letters, right? The formula is here. How do you do it? 4 factorial multiplied with 1 minus 1 by 1, 1 minus 1 by 1 factorial plus 2 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. Till n you have to do, right? Minus plus minus plus, that you have to, plus minus plus minus, you have to revolve like this, and then till 4 factorial you have to do. This is in this way we can dearrange. None of the 4 letters will go to their designated address. This is the way in which none of the 4 letters will go to its designated address. But what is the question saying? Right? Question is saying that only one letter goes to its address. Now, which one letter you have to choose? Which letter goes to its address? How will you choose? Out of 4 letters, 1 letter you will choose which will go to its address. The remaining 3 should not go to their address. So remaining 3 should be dearranged. How will they be dearranged? Multiplied with 3 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. This is how. Now just calculate this. Okay, so 4c1, that means 4 multiplied with 3 into 2, 6 multiplied with, what is this? 1 minus 1, 0 plus 1 by 2 minus 1 by 6. 1 by 2 minus 1 by 6. 4 by 12, that means 1 by 3 into 1 by 3. So 8. There are total 8 ways in which only one letter which we have chosen will go to its address and remaining 3 will be dearranged. They will not go to their designated address. This is how dearrangement is done. Remember this also. Okay, sometimes they ask questions based on this. Sometimes, very rarely, but yeah, they might ask questions based on this. Dictionary problem means finding the your rank of the given word. Finding the rank of given word. So it's very simple, right? Then the position of word small will be with or without, meaning if we arrange all the words forming from the letters of the word small, in that case which position will be for the word small? So first of all the words which are starting from A will start from A, remaining 1 2 3 4, right? 1 2 3 4, remaining 4. Okay, starting from A, how many words will be formed? All the letters which are starting from A. So arrange, how many arrangements are possible for these? S, M, L, L. S, M, L, L, that means 4 letters, where L is repeating 4 by 2 factorial. L is repeating 2 times. All the letters starting from A are done. Then after A comes L, M, M, L, L, M, L, 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 right? So now 1 2 3 4. 5 letters, na? 1 2 3 4, starting from L. Now one L is already fixed, remaining 4. How many are left? L is, one more L is left, S is left, M is left, A is left. So for this 4 factorial ways, all the letters starting from L are done. After L comes M. So from M, all the letters starting from M, again 4 factorial divided by 2 factorial, because there are 2 L's, right? After A, L, M, N, A, L and M, S will come. A is done, L is done, M is done, now S will come. But starting from, in S now we'll have to be very observative. In S, after S, smallest letter will be A. So first we'll see the letters which are starting from SA. So remaining 3. L, L and M. That means 3 factorial divided by 2 factorial. Okay. Now SA are done. After SA, SM will come or SL will come? SL will come. All the letters starting from SL will come. So these will be 3 factorial. Because one L is included, M, L and A. That we'll have to arrange. So 3 factorial words will be there. After SL, SM will come. After SL, SM will come. In SM also, SMA will come. Because after SM, first letter is A, then L and L, right? So right after where all the words starting from SL are ending, first letter which appears will be SMA. Why? Because SL is ended, now SM will start. In SM, SMA will come first. In SMA also, SMA, LL will come first. This letter will appear in the first. So 4 factorial by 2 factorial, 4 3 12 plus 24 plus 12 plus 3 plus 6. This will be the sum. What is the sum? 24, 24, 48, 48 plus 9. 57. Right? The sum is 57. Till here, the sum is 57. So small will be 58th word. Remember, small will be 58th word. Small is going to be the 58th word. Okay. Now this problem came this year. If the word of without meaning Kanpur are arranged in dictionary, then the word at 440th position. The word at 440th position will be which one? Right? So first start from A. What all words do you have? Which are all are different, right, over here. So from A, how many will have? 1, 2, 3, 4, 5. 5 factorial. Starting from A. Starts with A, right? You have to make all letters you have to use, right? So 1, 2, 3, 4, 5, 6. So 6 lettered word you have to make starting from A if you choose. So 5 factorial. All words starting from A will be completed. Similarly from K will be completed. After A, K will come, no? K will come. So this will also be 5 factorial. 120, 120, 240 done here only. Now A, K, L, M, N, O, P, N. So from N also 5 factorial. 360 are done till here, right? Now A, K, N. A, K, N. Now you look in the options. In the options we have PR, 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 PR. Right? PR we have to observe it. So we have to look at the words which are starting from P. So now start observing. After A, K, and N, O, P. Yeah, P will come. Right? So first we'll do with PA. All the letters which are starting with PA, because we have to look at PR. We have to go till PR. Okay, PR. Now this is till here we have done 240 plus 120. 360 are done. 440th we have to reach at. So PA. 3, yeah. So this will be 4 factorial. Right? All the letters which are starting from PA will be 4 factorial. So PA, after A comes K. Right? So then PK. This will also be 4 factorial. After PK, N will come. Right? After PK, PN will come. So these will also be 4 factorial. Correct? Because we are looking at PR. Correct. So far 360 plus 24, 24, 24. 408, 432. We have reached till 432. Right? We have reached till 432. Now we'll come at PR. In PR also PRA. But PRA is not there in any of them. So 1, 2, 3. That means 3 factorial. Okay. Okay, so this is PRA, 3 factorial, 1, 2, 3, correct. PRA is also not there. PRK or PRN we have to observe it. After A comes PRK. Acha, what is the sum till now? 48, 72, 360 plus 72. So it will become 432. 432 plus 6, 438 we have reached. Right? So PRK, A and U. After A will come PRK, A will come, N will come, and U will come. Right? PRK, A and U will come first. This will be your 439th word. This will be 439th word. Right? And PRK, A, U, N. PRK, A, U, N will be your 440th word. PRAK, A, U, N is there in the options. This will be your 440th word. Correct? Till PRA, till after PRA, PRK will come. In PRK also PRK, A, and U alphabetically. Then PRK, A, U, N will come. Then PRKN, those words will come, right? So 440th will be PRKAUN. This is how questions can be asked on dictionary problem. Dearrangement problem also you saw. Now third is this type of problem, divisor and sum of divisors. Now simple thing, number of, for example, if we are asking for number of divisors, all right. Suppose for A, we are solving for A. Right, suppose we are doing for A, number of divisors of 2 to the power 2 into 5 to the power 2 into 17 to the power 1. Now whichever divisor is going to be here will be of this form: 2 to the power A, 5 to the power B, and 17 to the power C. Now this A can be 0, 1 or 2. A can be 0, 1 or 2. Similarly B can be what? 0, 1 or 2, maximum 2. right? More than that will not divide it, right? Similarly, C can be what? Either 0 or 1. So 3 choices for A, 3 choices for B, and 2 choices for C. That means 18 will be the number of divisors of this particular number. There will be total 18 divisors for this particular number. Now for B, number of even divisors, that means 2 to the power 0 cannot be possible, right? Because 2 has to be there. If it wants to be even, then in the denominator 2 has to be there. If the number has to be even, if the number of even divisors we are asking, then in this A cannot be 0. 2 to the power 0 cannot be there. 2 some power has to be there. So that means 2 ways of A, 3 ways for B, and 2 ways for C. 12. Total will be 12. Okay. Now number of odd divisors, total divisors minus even divisors. That means 6 will be odd divisors. Total divisors minus even divisors. That's it. Okay. These type of questions can also come. Sum of divisors, for example, sum of divisors always, see, sum of divisors, if I explain you, either 2 to the power 0 can be there, correct, or 2 to the power 1 can be there, 2 to the power 2 can be there, 2 to the power 3 can be there, right? Similarly, 3 to the power 0 can be there, 3 to the power 1 can be there, 3 to the power 2 can be there, and similarly 7 to the power 0 plus 7 to the power 1 plus 7 to the power 2 can be there. These can be the divisors. These can be the sum of divisors of 2, for 3, for 7. Now when you will multiply them, right, this thing only will come, na? This thing only will come. Look at this. Number of divisors for A to the power m, B to the power n, C to the power q will be A to the power 0. Actually, we have written this thing only. We have written this thing only. Correct? So that's it. These can be the sum of divisor of 2. For 2, these can be the sum of divisors. For 3, this is the sum. For 7, this is the sum. So just multiply this. Now, how to multiply this? This will be nothing but 2 to the power 4 minus 1 divided by 2 minus 1. N to the power 4, and sorry, number to the power m minus 1 divided by 2 minus 1. This will be what? 3 to the power 2 minus 1 divided by 3 minus 1. This will be 7 to the power 2 minus 1 divided by 7 minus 1. This only you have to do. Oh, 3 to the power 3 and 7 to the power 3. 3 elements are there, no? 3 elements are there. Number of elements. Number of elements like this. Sir, thank you for physics has done very transparent. I'll ask sir to complete here also, beta. I'll ask him to complete here also. Right? These type of questions do come in advance. Remember that. Very simple question they'll be. Simple technique also I'm telling you. Sum of divisors if you have to tell. Right? Start from 0, go till 3. Start from 0, go till 2. Start from 0, go till 2. That will be the sum of divisors. This is how you find the sum of divisors. Now, find the exponent of 2 in 40. How to do this? Very simple. Right? Very simple. How to get the exponent of 2 in 40 factorial. Remember the way. Okay. Now, what is the highest power of 2, which can be divided, like, which comes below 40? 2 to the power 5 is the highest power of 2, which is below 40, because 2 to the power 6 will become 64, which is above 40. Okay. So, till 2 to the power 5, keep finding the greatest integer function. Just apply greatest integer function, 40 divided by 2, greatest integer, plus 40 divided by 2 to the power 1, greatest integer, plus 40 divided by 2 to the power 2, greatest integer, plus 40 divided by 2 to the power 3, again greatest integer, plus 40 divided by 2 to the power 4, again greatest integer, plus 40 divided by 2 to the power 5, greatest integer. Now 40 divided by 2 to the power 6 will give us 0, right? Greatest integer 2 to the power 6 is 64. 40 divided by 64, if we do, it will come 0 point something. Greatest integer will make it 0. How much will this come? This will come as 20. This again will come as, sorry, this will start from here. 2 to the power 1 only will start from, right, 2 to the power 1. So this will come as 20. 40 divided by 4, 10. Okay, 40 divided by 8, greatest integer, 5. 40 divided by 16, greatest integer. Greatest integer of 40 by 16 will be, 40 by 16 is 2 point something, right? 40 by 16 is 2 point something, so greatest integer will be 2. 40 divided by 32 will be 1 point something, so greatest integer will be 1. Now that is your answer. That means 35, 37, 38. 38 will be the exponent of 2 in 40 factorial. And if you pay attention, you can simply understand the reason also for this. Okay, now for example over here, look, 40 divided by 3, 40 divided by 3 square, 40 divided by 3 cube. We cannot do 3 to the power 4 because it will go above 40. Now look at this, exponent of 6 in 40 factorial. In this case, exponent 6 is made by 3 and 2. So we have to, exponent of 6 will be the lowest of the exponent of 2 and 3. For example, in 40, exponent of 2 will be what? 40 divided by 2 plus 40 divided by 4 plus 40 divided by 8 plus 40 divided by 16 plus 40 divided by 32, right? Greatest integer of all of them. We just now found it. It came out to be equal to 38, right? This is exponent of 2. Okay, now exponent of 3. How much is this coming? 13 plus 9, 4s are 36, 4 plus 1. Okay, so this becomes 18. Now exponent of 3 is 18 and exponent of 2 is 38 only. If you want to make 6, you need to club 3 and 2, but there are only 18 3s. So exponent of 6 will also be least of these two. Exponent of 6 will be 18. Why? Because for making 6 you need 3 and 2 both. You have only 18 3s. So for that only 18 2s will be available. So to make 6. So exponent of 6 will become 18. That's it. Very simple to understand this. Alright. Let's go ahead. Now one thing is circular permutation and circular arrangement. The formula is nothing but n minus 1 factorial. If you want to arrange n elements in a circular arrangement, right, then number of ways are given as n minus 1 factorial. If you are arranging in a necklace or a garland, now in necklace or garland, what is the problem? The problem is that you look in the necklace and garland from either of the side, right side or left side, they look same. Anti-clockwise and clockwise will not be different, right? If you are arranging n objects in a garland, you look from anti-clockwise side or clockwise side, the garland looks same or necklace looks same. So that means total number of ways will be nothing but n minus 1 factorial by 2. That's it. Remember this, right? For example, arranging 5 distinct objects in circle will give us 4 factorial, 5 minus 1 factorial, and this will be 5 minus 1 factorial by 2. That means 4 factorial by 2. This will be your A, this will be your B. Very simple. Okay, 4 factorial and this will be 4 factorial divided by 2. Alright. This question, out of 10 beads of 10 different colors, how many necklace can be made containing 4 beads of different colors? Come on, think about this. Right? First, what you'll have to do, 10 beads are there of 10 different colors. How many? Containing 4 beads. Your necklace needs only 4 beads. So first you'll select 4 beads out of 10. And then you'll arrange these 4 beads in necklace. In necklace, how do you make the arrangement? 4 minus 1 factorial divided by 2. That means this will be 10 factorial divided by 6 factorial into 4 factorial. So 10 into 7 into 6. 10 into 9 into 8 into 7 divided by 4 factorial. 4 into 3 into 2. So 2's are 8, 3 3's are 9, 2 got cancelled. 30 into 7, 210 multiplied with 3 factorial divided by 2. So that means into 3. So there will be 630 total number of ways will come. Right? Total will be 630 ways. This question was asked. A number of ways in which 5 girls and 7 boys can be seated at a round table so that no 2 girls sit together. Right? Here you'll have to use the gap method also. Right? Here you'll have to use the gap method also. In how many ways in which 5 girls and 7 boys can be seated at a round table so that no 2 girls are seated together. So let's say boy 1, boy 2, boy 3, boy 4, boy 5, boy 6, boy 7 you have. These are your 7 boys. Now girls you will have to keep in these gaps. How many gaps do you have? 1, 2, 3, 4, 5, 6 and 7 gaps you have. Correct? 7 gaps you have. To arrange the girls in these 7 gaps. Right? To arrange the girls in these 7 gaps. From 7 gaps, you want to arrange only 5 girls. So first from 7 gaps, you will select 5 gaps. Any 5 gaps. 7 gaps are created. From these, you will select any 5 gaps. Right? And in these 5 gaps, you will arrange the girls. But girls in these 5 gaps, that's not a circular arrangement now. When you are arranging in gaps, that's not a circular arrangement. Right? You will arrange these 5 girls in 5 factorial ways only. But these boys, right, 5 gaps, no, 1, 2, 3, 4, 5 gaps are very simple gaps. In 5 gaps, 5 girls to be arranged, not circular arrangement. That will be considered as linear arrangement only. So 5 factorial. But for boys, it's a circular arrangement. 7 boys arranged in the circle. First, you arrange 7 boys in the circle. What was your first step? First, you arrange 7 boys in the circle. How many ways to arrange 7 boys in the circle? 7 minus 1 factorial. That means this will give you 6 factorial into 5 factorial into 7. See, 5. First, you arrange 7 boys in the circular arrangement. After this arrangement, now your arrangement is not circular. It has a starting and ending point. Circular arrangement means it does not have a starting and ending point. That's why we do minus 1. But now it has a starting and ending point. From these 7 gaps which are created, 5 gaps you'll select and you'll arrange 5 girls in these 5 gaps. That's it. Okay. So that will be your answer. This is about circular arrangement. Now let's come to the distribution of objects. Very important, sometimes complicated, but it's a very important thing. Let's understand. Okay. Just a minute. Now, let me start with a simple example. Let's say there are, we also call distribution as, in some books you will read beggar's method. What happened over here? In some of the books, you will also study about beggar's method. So what is this beggar's method? Beggar's method means, sorry, suppose you have 3 people. No, suppose you have 3 chocolates, chocolate 1, chocolate 2, chocolate 3. And you have 4 beggars, beggar 1, beggar 2, beggar 3, beggar 4, beggar 5. You want to distribute these chocolates in these beggars, 3 chocolates and 5 beggars. Okay, so you will take chocolate 1 and think which one to give. For chocolate 1, how many methods you will have? 5 methods. You can give it to beggar 1, beggar 2, beggar 3, beggar 4 or beggar 5. Any of the beggars you can give it. So for chocolate 1, you have 5 options. Similarly, for chocolate 2, you have 5 options. For chocolate 3, you have 5 options. So how many ways, in how many ways did you distribute it? 5 to the power of 3. This is the method of distribution. First method, first thing. If you have n things to be distributed among m people, then m to the power of n will be your answer. Is it? No. m to the power of n will be your number of distributions. Correct? Did you understand this? Simple way of understanding. 3 chocolates to be distributed among 5 people. So for chocolate 1, you have 5 ways to distribute. Beggar 1 can take it, beggar 2 can take it, 3 can take it, 4 can take it, or 5 can take it. For C2, you also same thing. For C3, also same thing. So 5 to the power 3. So when we have n things to be distributed among m people, then m to the power of n will be the number of distributions. To remember this, you can remember it like this. Whoever is giving stays above. Whoever is the giver stays above. So 3 is above 5. Whoever is taking stays below. Whoever is giving stays above. Like that, right? Number of distribution. Number of ways of distributing n distinct objects among m persons is m to the power of n. N distinct objects, right? 3 different. So 4 chocolates to be distributed among 10 people. That means 10 to the power of 4, right? If we have 5 chocolates to be distributed among 3 people, so 3 to the power of 5. For example, while distributing the distinct objects, always see the number of options that a given objects to be distributed has. Okay, yeah, right, correct. For example, let's do this. In how many ways 5 distinct chocolates can be distributed among 4 students? Who is the giver? Chocolates are the giver. So chocolates will stay distributed among 4 students. 5 different chocolates to be distributed among 4. C1, C2, C3, C4, C5. Right? 5 different chocolates you have, and to be distributed among students are 4. So for C1 you will have 4 options. C2 also 4 options. C3 also 4 options. So 4 to the power 5 will be your answer. Whoever is the giver, chocolates are the giver, stays above. Who is taker? Students. 4 students, so 4 will stay below. You can think any way you want, right? Now, in how many ways 3 distinct chocolates can be distributed among 4 students? Who is the giver? Chocolates, right? So 3 will stay above, 4 students will stay below. That's it. Okay, this should be very, very clear. Distributing questions are very easy and they come very often, right? They do come very often. Okay, now pay attention at this problem. In how many ways 3 distinct chocolates can be distributed among 4 students such that no student gets more than 1 chocolate? See, every problem in PNC you have to very carefully think with counting, and there you can use the concepts that we have learned. But first see, what are we actually doing? What are we doing? 3 distinct chocolates, that means C1, C2, C3. We are distributing among 4 students, S1, S2, S3, S4. No student gets more than 1 chocolate. More than 1, nobody will get. Okay. But 3 chocolates only are there and 4 students are there. That means there will be 1 student who will not get any chocolate. Right? There will be 1 student who will not get any chocolate. Or we can say we have to select any 3 students from these 4 first to distribute the 3 chocolates. First we'll select any 3 students. 4C3 or 4C1, same thing only. Don't worry, that is the reason. 4C3, selecting 3 from 4 or selecting 1 from 4, same thing only. Selecting 3 means rejecting 4. Selecting 3 means rejecting 1, right? So 4C3, with this we are selecting 3 students from these 4. Now we'll distribute 3 chocolates in 3 students. 3 chocolates in 3 students. 3 chocolates are there, 3 students are there. Everybody should not get, anyone should not get more than 1. Right? So 3 chocolates now. So basically we are just arranging the 3 chocolates in these 3 students. No, we are arranging the 3 chocolates in these 3 students. For example, three people are left. Okay, 3 people are left, 1, 2 and 3 now. Right? 4, first we selected 3 and now we are arranging. So for first one, what choices we have? We don't give any chocolate. we give one chocolate, right? For this, what do we have? What are the options? We don't give any chocolate, we give one chocolate, or no student should get more than one, right? No chocolate or one chocolate, two options here. No chocolate or one chocolate, two options here. No chocolate or one chocolate. That's it. Wait. We are doing no. Ha. So here we are arranging. Sorry, I was saying here we are actually arranging three chocolates in three different places. So these three can go to any one of them, right? Either this or this. No one will have more than one. That means 3 into 2 into 1, right? Arrangements only. 3 chocolates in 3 students. Nobody is getting more than one, right? Nobody is getting more than one. So basically we are just arranging 3 chocolates in 3 students. If nobody is getting more than one, this formula m to the power n only works when we have no restriction. If we have a restriction, then we'll have to think of it with the help of selection and arrangement, right? So here first we selected the students which are getting the chocolate, then we distributed these 3 distinct chocolates in these 3 students. Distribution means arrangement in this case, because nobody gets more than one. Nobody can have 2. If anybody has 2, one will remain with no chocolates, right? If nobody can have more than one, that means this is just arrangement. Think of it like this. I hope you understand. Now another type of distribution, when we have, suppose we have 15 things, and these 15 things are to be distributed such that 10 are in one bag and 5 are in one bag, right? We are making bags, right? Suppose we have m plus n things, where number of ways of forming groups or packets, bags, packets, whatever you want to call it. Suppose you have m plus n things, where m things are in one bag and n things are in another bag. You have to distribute 15 things in the bags of 2. One bag contains 10 things and one bag contains 5 things. How will you do it? M plus n whole factorial. Okay, you'll do it like this: m plus n whole factorial divided by m factorial into n factorial, right? M plus n whole factorial divided by m factorial multiplied with n factorial. Here also again same thing, 15 factorial divided by 10 factorial into 5 factorial. Here again 15 factorial distributed in a bag of 3, bag of 5, bag of 7. So 3 factorial into 5 factorial into 7 factorial. That's how you do it, right? Suppose this one, 12 things to be distributed, 3. One bag should contain 3, this bag should also contain 3, this bag should also contain 3. So what will it become? 12 factorial divided by 3 factorial into 3 factorial into 6 factorial. Now how many bags are of same strength? 2 bags are of same strength, so we'll multiply with 2 factorial also. In this case 12 factorial divided by 2 factorial into 2 factorial into 2 factorial into 3 factorial into sorry, wait here. This will just be 12 factorial divided by 3 factorial. One bag is of 3 factorial, 3, one bag is of 6 factorial, and 2 bags which are of same strength, so 2 factorial. Now here 12 factorial divided by 2 factorial multiplied with 3 factorial. One bag is of 2 factorial, one bag is of 3, one bag is of 2, one bag is of 3. Now 3 bags are of 2, so 3 factorial, and 2 bags are of 3, so 2 factorial. Like this you're supposed to do it. Please note this down. Please note this down. Any doubts? Array, sorry guys, I'm writing wrong. Sorry. This will be same. I was correct only first time. 3 factorial into 3 factorial into 6 factorial. First write it like this. Then the repeated things. 3 is repeating 2 times. So 2 factorial for that. That's it. And here also 2 factorial. 2 factorial multiplied with 2 factorial multiplied with 2 factorial. So 2 factorial to the power 3 you can do. And then 3 factorial to the power of 2 because it is repeating 2 times, and now 2 is repeating 3 times, so for that multiply with 3 factorial, and 3 is repeating 2 times, so multiply with 2 factorial. This was correct. Actually you can think also for 12C3, 12C3, 12C6, that only selections only we are doing, so this will be the correct answer, but I'm just telling you a shortcut for that. For example, this question, 6 distinct books have to be distributed among Ram, Sham and Gopal. In how many ways can it be done such that Ram gets 1 book, Sham gets 2 books and Gopal gets 3 books? Okay, so total number of ways will be nothing but 16 factorial divided by 1 factorial multiplied with 2 factorial multiplied with 3 factorial. That's it. This will be the answer. Okay. One gets 3 books, one gets 2 books, last one gets 1 books. So same way, right? 3, 2, 1, right? And now here they are so saying in how many ways it can be done such that it has to be arranged also, right? It has to be arranged also. It is going to be arranged as well. Because the names are not mentioned. No, Ram, it's not defined. See, what is the difference between last question and this question? Here it is defined. Which one gets how many books? This is Ram's bag, this is Sham's bag, and this is Gopal's bag. But in the second question, it is not, one gets 3 books, one gets 2 books, one gets 1 book, right? Here also 16 books are being distributed in a pack of 3, in a pack of 2, and in a pack of 1, right? Answer will be 16 factorial divided by 2 factorial into 3 factorial into 1 factorial, correct? This will be the answer. But here these 3 packets can be with any of the 3 packets are being formed, no, and these 3 packets have to be arranged between Ram, Sham and Gopal because it's not mentioned which one is getting which one. So that's why we'll multiply with 3 factorial also. It is not mentioned which one is getting which books. Please don't stop putting lectures even if views are very less. Yes, monk mode, definitely yes, don't worry. Okay, Ram gets 4 books while Sham and Gopal gets 1 books each. So what, 6 books, 16 or 6? In the last one it was 16, na? Arre, why am I writing 16? 6 only, da. Day. Oh, leave it. 6 factorial divided by 4 factorial multiplied with Sham and Gopal both are getting 1, right? This is like this, 6, 4, 1 and 1. So 2 packets of 1 factorial, na? 2 packets of 1 factorial. Right, so how do we distribute 6 factorial divided by 4 factorial multiplied with 1 factorial multiplied with 1 factorial multiplied with 2 factorial because 2 packets of 1 are there multiplied with 2 factorial. Okay, so I think 6 ways only. This should be 6 factorial upon 2 factorial, right? And yeah, in the end, these 2, Ram and Sham, both get 1 book. So these 2 also have to be arranged because it's not mentioned which one gets which packet. So these 2 also have to be arranged. Don't forget that. 2 factorial will be multiplied. Same type of question. This again, each group contains at least 2 students. No group is empty. Right? Here again, you'll have to make cases, nothing else. So just make cases. Possible cases will be 2 to 5 group you can make, 2, 3, 4 group you can make, 3, 3, 3 group you can make. So these will be the total number of distributions in which you can do this. Now one type of problem which is this. Okay, this is also called beggars, not beggars method, I should not call it, not a good name. Number of ways in distributing n identical objects. Till now we learned distribution of unlike objects. Now distribution of like objects. N identical objects among R people if each person may receive any number. Okay, suppose you have 1 rupee coins, 5 1 rupee coins, right? And you want to distribute it in three beggars, beggar 1, beggar 2, beggar 3. Now beggar 1 can have 0 coin, no coin, 1 coin, 2 coin, 3 coin, 4 coin or 5 coin, right? So 6 options will be there, right, for beggar 1. For beggar 2 again 6 options, for beggar 3 again 6 options. Now this one can go with this one or this one. This one can go with this one or this one. This one can also go with this one. This one can go with this, right? So the total number of ways in which you can distribute 5 1 rupee coins among 3 beggars will be 5 plus 3 minus 1 C 3 minus 1. That's it. Remember the formula. To distribute n identical objects among R people, the number of distributions or number of ways will be n plus R minus 1 C R minus 1. For example, this question, 10 identical 1 rupee coins to be distributed among 3 beggars will be 10 plus 3 minus 1 C 3 minus 1. That means 12 C2. There will be 12 C2 ways to do this. And this is basically, these type of things are basically used, this particular distribution is used to solve these type of problems mainly. For example, x plus y plus z is equal to 12 and x plus y, x, y and z are all greater than 0. What are you doing? You are distributing ones. How many ones? 12 ones you are distributing, right? 12 ones. You are distributing 12 ones among x, y and z. 3 beggars are x, y and z. Sum of these 3 should be equal to 12. So that means you are distributing 12 ones in x, y and z, where x, y, z are integral solutions, so x, y, z are integers. So now x can be 3, y can be 4, z can be 5. 7, 5, 12, right? Anything. This can have 4 1 rupees, this can have 3 1 rupees, this can have 5 1 rupees, this can have 0 1 rupees, this can have 6 1 rupees, this can have 6 1 rupees, this can have 0 1 rupees, this can have 0 1 rupees, this can have all the 12 1 rupees. So 12 objects to be distributed among 3 beggars. How many ways will be there? 14C 2 ways. In 14C 2 ways we can do this. Okay, now same case. Now here x should be greater than equal to 2. That means you already gave, out of 12 you already gave x 2. X already got 2, right? Y and z. So x already got 2. That means you have to distribute 10 objects in x, y and z, because x already has 2. No, already you gave, x should be greater than equal to 2. That means at least 2 he should have. So 2 you gave already. Now you are distributing from 10. So 10 different things to be distributed among 3 different beggars. It will be equal to 12C2. 12C2 will be your answer. 66. In this case again, give x as 1 and y as 2. So what will remain? 9. You already gave x 1 rupee coin, 1 rupee coin you have given to x, 1 rupee, sorry, 2 ones you have given to y already. How many are remaining? 2 plus 1, 3. So 9 will be remaining. Out of these 9, out of these 9 you have to distribute among 3 different beggars. That means 11C2 will be your number of methods. Okay, same thing. Same thing. Now minus 2 means you have taken from x. Minus 2 means you have taken from x. You have taken 2 from x. Minus 2 means 12 plus 2. You have taken 2 from x. And 1 means 12 plus 2 which you had. From that you gave 1 to y. Minus 2 means you took 2 coins more from x. That's why it became minus 2. And 1 coin already you have given to y. Okay, so what will this become? 14 minus 3, 13 things you have to distribute among 3 beggars. 13 plus 3 minus 1, C3 minus 1. That means 15C2. Okay. Wait. Oi, 14. What is wrong? Wait. 13, yes. I think there should be a mistake in the answer. Yeah, answer should be correct. This should be correct. Yes, we took 1. We took 2 from it, so it became 13. All right. Oh, z is greater than 0. Z is given greater than 0, not greater than equal to. Greater than 0 means it should be greater than equal to 1, right? Integral solutions, no. So this means z should be greater than equal to 1, right? So 2 we took, minus 2 means we took 2 from the beggar, that means it became 14, right? Now plus 1 means from 14 will give 1 to y, that means it will become 13, and again plus 1, so 13 minus 1, that will become 12. Now 12 things we are distributing among the 3 beggars, so 12 plus 1, 12 plus 12 plus 3 minus 1 C 3 minus 1, that means 14C2. Yes, 14C2 was the correct answer. Z greater than 0 means Z greater than equal to 1. In this case, you will just make cases. X can be 1, X can be 2, X cannot be 3, right? X can be 0, X can be 1, or X can be 2, right? So you make 3 cases: when X is 0, when X is 1, and when X is 2. When X is 0, that means Y and Z. X is 0, Y and Z only, you'll have to distribute among Y and Z only, right? So 3 cases you are going to make, that's it. When X is 0, Y plus Z will be equal to 8, right? Number of integral solutions will become how much? 8 things to be distributed among 2 people. That means 8 plus 2 minus 1, 9C 1, that means 9. For X equal to 0, you will have 8 plus 2 minus 1 C 2 minus 1, that means 9. Okay, when X is 1, when X is greater than equal to 1, right? X can be greater than equal to 1 also, or X is equal to 1, that solution you can take. So Y plus Z will be how much? 5. Y plus Z will be equal to 5. So number of integral solutions, this will give you Y plus Z equal to 5, right? So 5 you have to distribute among 2 beggars. 5 plus 2 minus 1 C 2 minus 1. So that will be 7, 6 C 1, that means 6. That will be 6. 5 among 2 beggars, 5, 7, 6 C minus 1, 6. Right, 6 solutions you'll have. When X is 2, Y plus Z will be equal to 2. So Y plus Z will be equal to 2. That means you have to distribute 2 plus 2 minus 1 C 2 minus 1, that means 3. Right, total will be 9 plus 6 plus 3. Total number of ways will be just 9 plus 6 plus 3. Okay, this question, and the problems on this will be very easy. Number of ways in which 21 identical apples can be distributed among 3 children such that each child gets at least 2 apples, right? 3 children, let the 3 children to be X, Y, Z, right? X should be greater than equal to 2, Y should be greater than equal to 2, and Z should be greater than equal to 2. Each child gets at least 2 apples, at least 2, right? And X plus Y plus Z should be equal to 21, right? Where X is greater than equal to 2, Y is greater than equal to 2, Z is equal to 2. So 2 plus 2 plus 2, 6 you have already given. Out of 21 you have given already 6. So remaining 15 in 3 beggars, 15 plus 3 minus 1, C 3 minus 1. 18 minus 1, 17, C 2 will be your answer. Calculate it and you'll have your answer. 136 will come as your answer. Total number of 3-digit numbers whose sum is equal to 10. Directly you can give this. X plus y plus z is equal to 10, where x is greater than equal to 1, y greater than 0 and z greater than equal to 0. X is greater, x plus y, simple problem, x plus y plus z equal to 10, where x has to be greater than equal to 1. Why? Because first digit cannot be 0. It has to be greater than 0. So greater than equal to 1, y greater than equal to 0, z greater than equal to 0. That means out of 10, one thing already given. In 3 beggars, 9 plus 3 minus 1, C 3 minus 1 will be your direct solution. So 11C2 will be your answer. See, these type of problems are very easy if you know this concept. Otherwise, you'll have to leave them. Okay, 54 should be your answer. I think 10C, 11C2 is 54. 11 into 10, right, divided by 2. That means 55 here. Right? Hey, 11 into 10, 11 into 55, 54 how? We are forgetting something. Oh, okay. X greater than equal to 1. X cannot be equal to 9, right? No, it can be here. What are we missing over here? Oh, sum of digits has to come. Yes, x cannot be 10. Correct. One case we'll have to, sum of digits should be equal to 10. That means all the 3 digits should be single digit number, right? It's a digit. Understand? Sum of digits should be equal to 10, right? So first digit can be 0. First digit cannot be 0. 1 to 9 it can be. Correct. And anyway, we have taken first digit greater than equal to 1. 1 to 9 only it can be. Right? It cannot be 10. But here we have included 10 also. When we are saying no, x is greater than 1. That means 1 to 10 we are all including. Right? But first digit, x cannot be 10. Minus 1 we'll have to do. Why? X cannot be 10. X cannot be 10. We have in this we are actually including x can be, we are taking x as 10, y as 0, z as 0. In that case also 10 will come, no? But x cannot be 10. Because first digit, how can it be 2-digit number? So minus 1, x cannot be 10. Right? So these type of problems you get to see in, yeah, we're done. Right? These type of problems you'll get to see in distribution. Now I request you to go through the entire lecture, try to solve. We have solved 20-25 problems also, 24, 23, 22. So many PYQs we have seen. All the techniques we have learned, all the types of questions which can come, and in those questions, what all techniques can be used, that we have gone through, that we have learned. So I request you all to go through the lecture once again, revise it, solve the questions on your own, and then we'll practice. Okay. Chaliye, bye-bye. Take care. Have fun. Thank you. Thanks a lot.